Hello friends, this video on Class 10 Math Crash Course is brought to you by ExamFear.com. No more fear from exam. Based on our analysis of the previous 5 to 10 years of question papers, we have categorized all the lessons in the syllabus into 3 categories. That is high, medium and low based on their priority. So some of the lessons like quadratic equations, arithmetic progression, coordinate geometry, applications of trigonometry, circles, surface areas and volumes, and probability. These are all high priority lesson, as in you can expect 3 to 5 questions from each of these lessons in your question paper. Then we have the medium priority lessons like real numbers, triangles, introduction to trigonometry and area related to circles. So for each of these lessons you can expect 1 to 3 questions or 2 to 3 questions per lesson. And then again you have the low priority lessons like constructions, pair of linear equations in 2 variables, polynomials and statistics, where you can expect 0 to 2 questions in the entire question paper. Now, this analysis that we have done is purely on the basis of the pattern of questions that comes from different chapters and different years of board exams. Quadratic equations. Some of the important topics or areas of quadratic equations are quadratic equations, solution of a quadratic equation by factorization, by completing the square, and nature of roots. So we will do a very quick recap of this entire lesson. So to start with, quadratic equation, as we all know, it is an equation in the form ax square plus bx plus c is equal to 0, where a is not equal to 0 and a, b, c are real numbers. Okay, so how do we use quadratic equations in real life situations? Let's look at this example. So it says that John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. So we would like to find out how many marbles they had to start with. Okay, so let's look at this situation. So let us assume that John had x marbles, because we do not know the exact number. So we are just assuming it to be a variable x. So if John had x marbles, so how many marbles Jivanti had? Because both of them together had 45 marbles. So quite obvious, Jivanti had 45 minus x marbles. Now the question also says that they both lose 5 marbles. So after losing 5 marbles, how many marbles John has? X minus 5. And how many marbles Jivanti has? 45 minus x minus 5. Right? The question also says that after losing 5 marbles, the product of the number of marbles they now have is 124. That means x minus 5 multiplied by 45 minus x minus 5 is equal to 124. So now if we try to do the calculations, we get 45x minus x square minus 5x minus 225 plus 5x plus 25. This is equal to 124. So minus 5x plus 5x will cancel out. So this will turn out to be minus x square plus 45x minus 200 is equal to 124. Again, if we shift 124 to left hand side, so we get minus x square plus 45x minus 324 is equal to 0, or we can say x square minus 45x plus 324 is equal to 0. So this is a quadratic equation. Right? So now comes the more important part, which is solving a quadratic equation. Now there are various methods to solve a quadratic equation, and one such method is factorization. So in factorization, what we do is we write the expression in terms of its factors. Let's take an example. 100x square minus 2x, 10 is 20x plus 1 is equal to 0. This is a quadratic equation. And how do we factorize it? So here we make use of a concept called midterm splitting. So what do we do? The midterm, that is 20x, we split it into 2 parts such a way that minus 20x is the sum of those 2 parts, such that the product of those 2 parts is equal to the product of the first term and the last term. So let's look at it. How do we do it? So let's divide minus 20x into 2 halves such that the sum of those 2 halves is minus 20x. So we can divide it like this, minus 10x minus 10x. So their sum is minus 20x. At the same time, these 2 halves should be such that their product, so here the product is 100x squared. So the product should be equal to the product of the first term and the last term, which is also true in this case. So therefore minus 20x, we can break it down as minus 10x minus 10x. This plus 1 is equal to 0. So now if we put together two terms and then take common out of them, so what do we get? So let's see. So in this case, we can say 10x is common. So we are left with 10x minus 1. And here we have minus 1 common. So we are left with 10x minus 1 is equal to 0. So we can say 10x minus 1 into 10x minus 1 is equal to 0. So in this fashion, we can actually factorize it. So from this, we can say that 10x minus 1 is equal to 0. So x would be equal to 1 by 10. So that's how we factorize it. Now let's look at the second method, which is by completing square. So what do we mean by that? So completing square means converting it to the form of x plus a whole square minus b square is equal to 0. So we have to bring it down to this form. Only then we say that it is in the form of completing squares. Right? So let's take an example of this equation. 2x square minus 7x plus 3 is equal to 0. So now if we have to bring this equation to this form, then the first thing that we have to do is we have to get rid of this 2, because it has to be in the form of x square plus a square. Only then we will be able to reach to this form. So for that, what do? We divide the entire equation by 2. So when we divide it by 2, we get x square minus 7 by 2x plus 3 by 2x. 3 by 2 is equal to 0. Right? Now what do? A square minus 2ab plus b square. So this 7 by 2 can be written as 2 into 7 by 4, right? So a square minus 2ab plus b square. We are trying to write it in that form. So 2 into x into 7 by 4. So 7 by 4 becomes our b. So b square. So if we write it this way, in that case, what we have to do? So what we are doing is, this is one additional term that we are adding to this equation. So therefore, we need to subtract this from this equation. So minus 7 by 4 whole square, and then we anyways had plus 3 by 2, which will remain as it is. So in this case, what do we see? This entire thing is in the format of a square minus 2ab plus b square. So this becomes a minus b whole square. And then we have here 49 by 16 plus 3 by 2 is equal to 0. So this is x minus 7 by 4 whole square minus 25 by 16 is equal to 0. Or this can be written as, so you see, this is exactly in this format, x plus a whole square minus b square is equal to 0. So x plus a, here a is equal to minus 7 by 4 and b is equal to 5 by 4, because 25 by 16 is 5 by 4 whole square. So we can write it like this, x minus 7 by 4 whole square is equal to 5 by 4 whole square. So this can very well be written as x minus 7 by 4 is equal to 5 by 4, or x is equal to 5 by 4 plus 7 by 4, which is equal to 12 by 4, that is equal to 3. So that's the value of x. There is other option that x minus 7 by 4 could also be equal to minus 5 by 4. That's because here we saw that x minus 7 by 4 whole square is equal to 5 by 4 whole square. That means x minus 7 by 4 could be equal to 5 by 4, or it could be equal to minus 5 by 4, because minus 5 by 4 whole square is also equal to 5 by 4 whole square. right? So both the options are possible. So in this case, x will be equal to minus 5 by 4 plus 7 by 4, which is equal to minus 2 by 4, that is equal to minus half or minus 1 by 2. So therefore, the roots of this equation are 3 and minus half. So in this pattern, we can find out the roots of an equation by completing the square. Now we will talk about nature of roots. Now this is another important topic. Now whenever we are given a quadratic equation, we are often curious to know what is the nature of root of this equation, whether the roots will be equal or the roots will be different and real, or the roots will be unreal. And how do we know that? Using the value of the discriminant, which is denoted by d, and the value is given by b square minus 4ac. Right? So what happens? What does d tell us? So it tells us that if the discriminant is greater than 0, that means the two roots are real and distinct. That means they are different. Their values are different and they are real values. If b square minus 4ac is equal to 0, that means the two roots are equal in value and they are real. And if b square minus 4ac is less than 0, that means the roots are unreal. They are not real numbers. Now let us look at this example. So we are given a quadratic equation like this, which is in the form of ax square plus bx plus c, such that the value of a is equal to 3, value of b is equal to minus 4 root 3, and value of c is equal to 4. So now we have to tell the nature of roots. So in order to do that, we will first calculate the value of discriminant, which is equal to b square, that is minus 4 root 3 whole square, minus 4 into a into c. So this is equal to 48 and this is equal to 48. So 48 minus 48 is equal to 0. So that means this particular equation has equal and real roots. Now let us look at some important questions from this chapter. So the first question is, okay, having said that, it is important to know that these are not questions which are going to come in your exams, but these are our guesswork based on our experience. Like this pattern of question might come in your exams. So first problem is, a train travels 360 km at a uniform speed. If the speed had been 5 km per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. So we do not know the speed of the train. So let us assume that the speed of the train is x km per hour. So if that is the speed of the train, then the time taken by the train to cover 360 km would be equal to 360 divided by x, that is distance divided by speed. So this would be the time taken in hours. Right? Now the question says that if the speed had been 5 km more, that means if the speed had been x plus 5, so in that case the time taken would have been, so then time taken would have been 360 divided by x plus 5, because the distance would still remain the same, right? So the question says that if the speed had been 5 km more, then the time taken would have been 1 hour less for the same journey. That means this time is 1 hour less than this time, right? So basically 360 by x minus 360 by x plus 5 is equal to 1 hour. So now when we solve this equation, we get 1 by x minus 1 by x plus 5 is equal to 1 by 360, or we can say this is equal to x into x plus 5, and on the numerator it would be x plus 5 minus x. This is equal to 1 upon 360. So x and x will get cancelled. So this would be 5 into 360 is equal to x square plus 5x, or we can say x square plus 5x minus 1800 is equal to 0. So this is a quadratic equation. So now our main task is to solve this equation. So we can go by the factorization method. So we will do a mid-term splitting. So first the mid-term, that is 5x, has to be split into two terms such that their product is equal to 1800 and their sum is equal to 5. So what we do, we split it this way. plus 45x minus 40x. So here the product is 1800 and the sum or the difference, whatever you call it, is 5. So this minus 1800 is equal to 0. So this would be equal to x into x plus 45 minus 40 into x plus 45 is equal to 0. So we see that x is equal to plus 40 or x is equal to minus 45. But we know that speed, what is x? X is the speed of the train. Now speed cannot be negative and therefore speed of the train is 40 kilometers per hour. Let's look at another problem. An express train takes 1 hour less than a passenger train to travel 132 km between Mysore and Bangalore, without taking into consideration the time they stop at intermediate stations. If the average speed of the express train is 11 km per hour, more than that of the passenger train, find the average speed of the two trains. Okay, so let us say that the average speed of the passenger train is x kilometer per hour and the average speed of the express train is equal to x plus 11 kilometer per hour, because it says that the average speed of express train is 11 kilometer per hour more than that of the passenger train, right? So now time taken by the passenger train, that is TP, will be equal to the total distance, that is 132, divided by speed, which is x. Similarly, the time taken by the express train would be equal to 132, that is the total distance, divided by speed, which is x plus 11. Right, and it says that the express train takes 1 hour less than the passenger train. That means the time taken by express train is lesser than the time taken by passenger train. We can say 132 by x minus 132 divided by x plus 11 is equal to 1. So now again in this case, if you solve this equation, because I'm not going to do all the calculations because that will unnecessarily waste our time, and right now we want to revise the entire syllabus. So I would ask you to do the calculations yourself and solve the equation. So in this case it would be like 1 by x minus 1 by x plus 11 is equal to 1 by 132. So this would be equal to x into x plus 11. So this is x plus 11 minus x is equal to 1 by 132. So plus minus x will get cancelled. So this would be equal to 11 into 132 is equal to x square plus 11x, or x square plus 11x minus 1452, that is 11 into 132. This is equal to 0. So this is our quadratic equation, and here also you can do midterm splitting. How you do midterm splitting? This 11x can be written as plus 44x minus 33x. So how do we find this midterm splitting? So basically one small trick that you can follow is, you have this 1452, right? So you start breaking it down into factors like this. So 2 into 7, 2 2s are 4, 2 8s are 16, again 2 3s are 6, 2 6 are 12, 2 4s are 8. Once again, 2 7s are 14, 2 2s are 4, 2 6s are 12. So this would be 3 6 3. Then this would be 3 1 2 1. Then this would be 11 into 11. So you see, you have broken it into factors. Now you can see which are the two factors that you have to consider. For example, whether it should be 11 into 11, 121 multiplied by 12. No, that doesn't work because the sum or the difference has to be 11. So other option could be 11 into 3 into 2, that is 66, and 22. So there also it doesn't work. Other option could be 11 into 3, 33, and 11 into 2 into 2, that is 44. So 33 and 44, yes, the difference is 11. So that works. So this would be plus 44x minus 33x. Here we have x square, here we have 1452 is equal to 0. So I think now you can very easily solve it and find out the speed of passenger and express train. So let us now move on to the next lesson, which is arithmetic progression, which is popularly known as AP. So in this lesson, some of the important topics are arithmetic progression, nth term of an AP, sum of first n terms of an AP. So basically based on these two concepts, you generally get questions like around them. So we will quickly look at the important concepts and also some important questions. So when it comes to arithmetic progression or AP, it is basically a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. And this fixed number is called common difference. So that means the general format of an AP is A plus D, A plus 2D, A plus 3D, and so on, and where A is the first term. For example, let's say we say 3. So 3 plus 4, 7, 4 plus 7, 11, 11 plus 4, 15, 15 plus 4, 19, and so on. So this is an example of AP where the first term, that is A, is equal to 3 and the common difference is equal to 4 because the difference between two successive terms is 4. Right? So that's an arithmetic progression. Now when we talk about arithmetic progression, one important thing is that the common difference remains the same. That means the difference between any two consecutive terms is always a constant. That means A2 minus A1, A3 minus A2, A4 minus A3, they are all equal. Right? Now, an AP can be a finite AP or an infinite AP. So any arithmetic progression that does not have a last term is called infinite AP. Right? For example, like in fact, this example, this is an infinite AP, 3, 7, 11, 15, 19, and so on. So like you do not really have a last term. It continues. So when I say give this dot, 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 that actually means that it's going on and on. So that's infinite AP. Whereas if we have an AP with a last term, so that's a finite AP. Let's say if we say 3, 7, 11, 15, 19. That's it. So in this case, this is a finite AP because 19 is the last term of the arithmetic progression. Right? Okay, so let's see how do we calculate the nth term and the sum of n terms. So in any AP, the nth term is given by this formula, which is A plus n minus 1 into D. Now, please understand that this is a quick recap video and therefore I am not going to talk about the derivations or the detailed calculation basically. So it's a very quick recap. So this is how you calculate the nth term of an AP. And how do we calculate the sum of first n terms, that is given by n by 2 2a plus n minus 1 into d, where a is the first term, d is the common difference, and n is the nth term that we are talking about. So let's say if we say that the first 10 terms of AP, so n becomes 10. Right, so that ways. Okay, so here also let's take an example. So as an example, we will again consider the same example 3, 7, 11, 15, 19 and so on. So in this case, if we have to find out the 10th term, that is A 10. So this becomes equal to A plus n minus 1 into D. So this is equal to 3 plus 9 into 4, that is equal to 39. So 39 is going to be the 10th term. Similarly, if we want to calculate the sum of first 10 terms of this AP, so in that case, S10 will be equal to 10 by 2 into 2 into A. A is 3 plus 10 minus 1 into 4. So I have just put values in this formula. So this comes out to be 210. So I'm not getting into the calculations. You can do it yourself. So 210 is the sum of the first 10 terms of this AP. Now there is another shortcut to calculate the sum of the first n terms of an AP, which is S is equal to n by 2 A plus L, where L is the last term of an AP. So that actually means that this formula works only when we are talking about a finite AP. Now let's look at a few questions. So let's look at the first one. Find the sum of the first 400 positive integers divisible by 6. Now first let's write that AP. So first few integers which are divisible by 6. So basically the table of 6. 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24 and so on. So we have to find out the sum of first 40. That means 40 is the value of n. So we have to find out Sn is equal to how much? Now Sn or S40 will be equal to n by 2. 2 into A is the first term, which is 6, plus n minus 1 into D. So common difference here is 6. So into 6. So when you calculate this, this comes out to be 5080. Moving on to the next example. If the sum of first n terms of an AP is 4n minus n square, what is the first term? Okay. What is the sum of the first two terms? What is the second term? Similarly, find third, 10th and nth terms. Okay. So this question says that Sn, that is sum of first n terms, is equal to 4n minus n square. So that means this first term, the sum of the first term, which actually is the first term, will be equal to 4 into 1 minus 1 square. That is equal to 3. So that means 3 is the first term, because sum of the first term is nothing but the first term. Right? So we found out the first term. Now let's calculate S2. So if we will put n is equal to 2, so this becomes 4 into 2 minus 2 square. So 8 minus 4, which is equal to 4. Now this 4 is the sum of the first term and the second term. Correct? So from this, so we can say this is the sum of the first two terms, and from this we can say that the second term is equal to sum of the two terms minus the first term. So 4 minus 3, that is equal to 1. So first term is 3 and second term is 1. Correct? Similarly, if we have to calculate S3, so this will be 4 into 3 minus 3 square. That is 12 minus 9, which is equal to 3. This is the sum of the first three terms. And this was the sum of the first two terms. Correct? So from this we can calculate what will be the third term. So this will be equal to the sum of the three terms, and from this we will subtract the first term and the second term. Right? So this is 3 minus, what is the first term? First term is 3, second term is 1. So this will be equal to minus 1. So minus 1 is the third term. So this AP, so finally if you look at the AP, it will look somewhat like this. It starts with 3, then 1, then minus 1, and then so on. So in this case, what do you see? What is the value of D? Difference is minus 2. That is, common difference is minus 2. And so on. Let's look at the third question. 200. Now, many a times, especially from this chapter on AP, so sometimes you have straightforward questions like how we discussed the first two questions. You have to find out the nth term or sum of few terms, etc. Now, sometimes you have real life questions, for example, this problem sum questions, which are based on the concepts of AP. So in this case, it's very important that you understand the question really well so that you are able to apply the right formula in the right way. So let's look at this question. 200 logs are stacked in the following manner. 20 logs in the bottom row, 19 in the next, 18 in the next, and so on. Like as you can see here. So the bottom line has some 20 logs, the next one has 19, the next one has 18, and so on. Now, in how many rows are the 200 logs placed and how many logs are in the top row? So basically, if you look at this series, this is like 20, 19, 18, 17, 16, and so on, right? So this is an AP, right? So the AP looks somewhat like this, 20, 19, 18, and so on. Right? Now, it says that Sn, that is sum of all the logs of wood, is 200. And this is not an infinite AP. This is a finite AP. Just that we do not know what would be the last number. So we do not know that n, but it is a finite AP because it has some finite rows. Correct. So in this question, we have to find out how many rows are there. That means we have to find out the value of n. And we also need to find out how many logs are there in the topmost row. That means the last row which we are talking about. So how many logs are there in that particular row. Correct. So we have to find out that. Right. So we have to find out the value of n, and we have to also find out the value of an. Great. So let's see, how do we calculate that? Now Sn is equal to n by 2 into 2a, a is 20, plus n minus 1 into d. So d here is minus 1. So now when you put all of these values and you actually calculate it, so what do you get? Because Sn is equal to 200. So instead of Sn, we will write 200 here. We'll do all the calculation and we will get an equation like this. 400 is equal to 40n minus n square plus n. Right? And then again, when you further calculate, you get n square minus 41n plus 400 is equal to 0. And then you solve this equation. So how do you solve the equation? N square minus 25n plus 16n, minus 16n plus 400 is equal to 0. So basically when you do all the calculations, you get n minus 25 into n minus 16 is equal to 0, which shows n is equal to 25 or n is equal to 16. But both the values are not possible. So let's calculate an now. So if n is equal to 25, so in that case, an will be equal to a plus n minus 1 into d, which is d is minus 1. So when you calculate this value, you get an is equal to minus 4. That means the number of logs of wood on the topmost row will be minus 4. Is that possible? No, because the number of logs cannot be in negative. So this is not possible. That means n is equal to 25 is also not possible. Now let's take n is equal to 16. So in that case, an will be equal to a plus n minus 1 into d. So this comes out to be 5, which is very much possible. So that means there are the total number of rows are 16 and the number of logs in the top row is 5. So basically the AP looks somewhat like 20, 19, 18, 17, 16, 15, 14, so on till 5. Right? So these are the kind of, real life situation questions that you get, which are based on the concept of arithmetic progression. Moving ahead with the next lesson, which is coordinate geometry. So coordinate geometry again is a high priority lesson. So you can expect questions, say 3 to 5 questions from this lesson. Some of the important topics are distance between 2-point formula. So that's like very, very important. Sectional formula, area of triangle. And now let's look at the distance formula. अब फटाफट देखते हैं. So let us now quickly take a look at distance formula, because this is one of the most important topics of coordinate geometry. So distance formula tells us the distance between any 2 points P and Q in terms of coordinates. As in, let us suppose the coordinates of P is x1, y1, Q is x2, y2. So what would be the distance between these 2 points? That is given by root over x2 minus x1 whole square plus y2 minus y1 whole square. And that's the distance formula. Now, here we also talk about another important concept of section formula. So what is section formula? So section formula tells us that the coordinates of a point P, which divides a line segment. For example, here you have a line segment AB. And you have a point P which divides this line segment internally in the ratio of M1 is to M2. So as you can very clearly see in the picture, so the coordinates of this point P will be M1 x2 plus M2 x1 divided by M1 plus M2, comma, M1 y2 plus M2 y1 divided by M1 plus M2. So basically that would be the coordinates of this point. That is, the value of x will be equal to this and the value of y will be equal to this. This will give us the value of x and this will give us the value of y. And that's how we get the coordinates of this point P. Now, a special case can arise in this case, which is if the point P is midpoint of AB. That is, if M1 is equal to M2, in that case, the coordinate of point P will be equal to x1 plus x2 by 2 and y1 plus y2 by 2. Now that's quite obvious, right? Because in that case, M1 and M2, they are equal. So that's section formula. And then we have the third concept, which is area of a triangle. So how do we normally calculate area of a triangle? So previously we used this formula, which is half into base into height. But now when we talk about the coordinate geometry, so here we mostly talk about the Heron's formula, which is A is equal to root over S into S minus A, S minus B, S minus C. Now you may ask, what is S? S is semi-perimeter of a triangle, which is given by A plus B plus C divided by 2. So that means you have to halve the sum of all the three sides of the triangle, and that's how you get semi-perimeter. And using semi-perimeter, you can use Heron's formula to calculate the area of a triangle. So now, even if you do not know the base and height, but if you know the length of the sides of the triangle, you can at least calculate the area of the triangle. So now, that's the Heron formula. Now, the new formula in terms of the coordinate geometry is area is equal to half x1 into y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. See, coordinate geometry is all about the coordinates. So we do not talk in terms of length of sides or the value of the angles. Rather, we talk about the coordinates of various points. Right? So if we say that, if we have a triangle where the coordinates of the vertices are known, that is, if this is a triangle A, B, C, and we know that the coordinates of A is x1, y1, coordinates of B is x2, y2, and coordinates of C is x3, y3. So in terms of the coordinates, this is how we calculate the area of the triangle. Now let's look at some important questions. In the following, find the value of K for which the points are collinear. Okay, so we are given coordinates of 3 points. Now let us call these points as A, B and C. Now the question says that we have to find out the value of K such that A, B and C are collinear. That means A, B, C should lie in a straight line. Now that would be possible when the area of triangle ABC is equal to 0. So because if for a triangle, if the area is 0, that means it is not at all a triangle. That means all the 3 points, they are lying on the straight line. That is why the area of that triangle is 0. Right? So how do we find out the area of a triangle? So just now we saw the formula. So we just use the formula of area, which is half into x1 into y3 minus y2 plus 5 into k plus 2 plus 3 into minus 2 minus 1. So we put all the values in the formula for area, and then we get this as minus k plus 4. So that's the area we get. But what we want is that area of triangle should be equal to 0. So that means the value of k should be equal to 4. Let's look at the next question. Prove that 4, minus 1, 6, 0, 7, 2 and 5, 1 are the vertices of a rhombus. Is it square? So we have to prove that this is a rhombus. Now what is a rhombus? So in a rhombus, like what's the main feature of a rhombus? In a rhombus, all the 4 sides are equal, just like square. But if it has to be a square, in that case, all the 4 angles should also be equal, right? Which is not the case of a rhombus. Okay, so first we have to prove that this is a rhombus, and in order to prove that, we need to find out the length of the sides. Okay, so here let's suppose this is point A, this is B, this is C and this is D. So first we have to find out using distance formula, we will find out the length of AB, that is distance between points A and B, which will be equal to root over 6 minus 4 whole square plus 0 minus minus 1, that is plus 1 whole square, which is equal to root over 5. Now we calculate BC, which is equal to root over 7 minus 6 whole square plus 2 minus 0 whole square, which is equal to root over 5 again. Now we calculate CD, which is equal to root over 5 minus 7 whole square plus 1 minus 2 whole square, which is equal to root over 5. And then we calculate dA, which is equal to root over 5 minus 4 whole square plus 1 whole square, which is equal to root over 5. So we see that all the four sides are equal, and that is why this is a rhombus. Now, in order to find out if it is a square or not, we need to focus more on the angles, because if it is a square, in that case, the angles should be equal to 90 degree, right? So let us draw this. So let us suppose this is A, B, C, D. So we already know that it is rhombus. That means all the four sides are equal. Now, for this to be a square, each of these angles which should be equal to 90 degree, correct? So in that case, in each of these triangles, the Pythagoras theorem should hold true, correct? So in that case, this BD square should be equal to DC square plus CB square. So this should hold true, right? So if this holds true, that means this is a square. So now let us try to find that out. So how do we find that? BD is equal to root over, this is B and this is D. This would be 5 minus 6 whole square plus 1 minus 0 whole square, which is equal to root over 2. So now if we actually check it now, we see that BD square comes out to be 2. So here BD square comes out to be root 2 square, which is 2, and DC square would be 5. BC square would be 5. So 5 plus 5 would be equal to 10. So obviously 2 and 10 are not equal. That means the Pythagoras theorem doesn't hold true here, which actually means that these angles are not 90 degree and therefore it is not a square. So even though these coordinates represent a rhombus, but this is not a square. So let's move on to applications of trigonometry, and this is a medium priority lesson and you can expect 2 to 3 questions from this lesson. Now some of the important topics from where you can expect questions are questions related to finding speed of aeroplane or distance between two aeroplanes or angle of an object. So generally you have questions related to such things. Width of a river, height of a building or height of a tower, hill, and so let's look at some of the questions. I think that will give us better clarity. So question number 1, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. So you see, when you read these kind of questions, even if the image is not given, you need to draw the diagram. So just understand the question really well. So you have a vertical pole like this. So let's say this is the vertical pole, and you have a rope which is tightly attached from the top of the pole to the ground. So basically this is the rope, right? And this is your ground. Right? So we have to find out the height of the pole if the angle made by the rope with the ground level is 30 degrees. So this angle is 30 degree. We have to find out this height. Correct? And the length of the rope is given as 20 meters. So this is my rough diagram and this is how it looks like. This is the circus artist. This is the pole. This is the rope. And again, as I said just now, we know that the angle that it makes is 30 degree. This is 20 meter and this is the height of the pole. So now from trigonometry, we know that sine 30 degrees. So here we are bothered about the perpendicular and the hypotenuse. So sine 30 degree is equal to P by H. So sine 30 degree value is 1 by 2. This is equal to P by H. So what is P? P is perpendicular, which in this case is the height of the pole. So this is the height of the pole divided by hypotenuse, which is 20. So therefore height of the pole will be equal to 20 by 2, which is equal to 10 meters. Let's look at the next question. The angle of elevation of the top of a tower from a point on the ground is 30 meters away from the foot of the tower. So let's say this is the tower and this is a point. So in this case, we have this tower and it says that the angle of elevation of the tower from a point on the ground. So this nail which is here on the ground, it just tries to show that point on the ground. So this elevation is 30 degree, right? So with the ground, it makes an angle of 30 degree. So we have to find out the height of the tower, right? And it also tells that the distance of this point from the tower, so let us look at this question now. The angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degree. Find the height of the tower. So this is the tower. So height of this tower has to be calculated. And let us suppose this is the point on the ground which is 30 meters away from the tower. That means this distance is 30 meters and also this angle of elevation is 30 degrees. So this is all that we have, and now we have to calculate the height. So here we are bothered about two values. One is this height, the other is this base. So basically here we will talk about tan theta. So tan theta is equal to perpendicular by base. So perpendicular here is the height of the tower and base is obviously this distance which is 30 meter. So with that we can say that height of the tower will be equal to 30 multiplied by tan 30 degree, which is 1 by root 3. So this is equal to 30 by root 3. So if you multiply root 3 on both numerator and denominator, you get 30 root 3 by 3, which is equal to 10 root 3 meters. So that's the height of the tower. Moving on to the next question. As observed from top of a 75 meter high lighthouse from sea level, the angles of depression of two ships are 30 degree and 45 degree. So this is the sea, this is the lighthouse. Now when you observe from the top of the lighthouse and there is one ship, this is another ship. So we see that the angle of depression, because now you are seeing from the top. So this is your angle of depression. So this is for 30 degree and 45 degree respectively. So this is 30 degree and this one is 45 degree. Right? If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the ships. So we have to find this distance. Right? So this is the height of the lighthouse and this line will denote the distance. So now this height is given as 75 meters. Right? What else is given? And the angles are given. Correct? Now looking at this diagram, basically we can say that if this angle is 45 degree, so this angle and this angle, they are alternate angles. So this is going to be 45 degree. Similarly, if this angle is 30 degree, this being alternate angles, this is also going to be 30 degree. Clear? Now this distance, let's say this distance is d, which we have to find out. This distance also we do not know. Let us call this x. We assume that this is x. So now for tan 45 degree, this will be equal to perpendicular by base. Base will be x. Similarly, for tan 30 degree, it would be equal to perpendicular, that is 75, divided by base, which will be x plus d. Right? So what is tan 45? Tan 45 is equal to 1. So 1 is equal to 75 by x, or we can say x is equal to 75 meters. So we got the value of x. Now in the second equation, tan 30 degree is 1 by root 3. This is equal to 75 divided by x is also 75 plus d. So from this we can say 75 plus d is equal to 75 root 3, or d is equal to 75 root 3 minus 75, which is equal to 75 root 3 minus 1 meters. So that's the distance between the two ships. Let us now move ahead to the next lesson, that is circles. Now this is a high priority lesson. However, when we did the analysis of the previous year's question papers, we found that sometimes it so happens that you hardly get any question from circles, whereas at some other times you end up getting 4 to 5 questions from this lesson. So we are not going to take any kind of risk, and therefore we will mark it as high priority. So some of the important areas from where you can expect questions are questions related to finding length of a tangent, radius of a circle, area of shaded region, quadrilaterals and circles, triangles and circles. So majorly in this particular section, you often get questions where you would see a quadrilateral inside a circle or a triangle inside a circle, and they would make some area shaded. They'll ask you to find out the area of that shaded region and things like that. So right now we are going to solve some of the questions, like generally the type of questions that are mostly seen in exams. So before that, let's do a very quick recap. So when it comes to this lesson on circles, a very important part is tangent. So tangent to a circle intersects it in one point, and that point is called point of contact. So let's say if this is a circle, this is a tangent. So tangent is basically a line which intersects the circle, like it passes out from outside the circle and it intersects the circle exactly at one point. And this one point is called the point of contact. At any point on a circle, there can be one and only one tangent. So let's say if you consider this particular point, so at this point you cannot have more than one tangent. The reason being, let's say, even if we assume that, let's say there's another tangent which is drawn like this. So in that case, that tangent, that is not going to be a tangent. For example, if you draw a line like this, that's not a tangent. And if you plan to draw a line like this, that has to be this line. Right? So at one point, only one tangent. Tangent at any point of a circle is perpendicular to radius through point of contact. So if you compare this line, that is the tangent, and if you look at the radius, you would see that it is always perpendicular to the radius. So let's say if this is the center of the circle and if this is the radius, so this angle is always 90 degree. Line containing radius through point of contact is called normal. So this line is called the normal. Okay, so a circle can have two parallel tangents at the most. So that's again another important fact. So here again, if you look at this particular image, you would see that in a circle, at every point you can have one tangent. But none of these tangents would be parallel. So the only parallel tangent that is possible is exactly opposite to this point. So a tangent drawn like this. So that is the only possible parallel tangent. So that means a circle can have only two parallel tangents, maximum, not more than that. Lengths of tangents drawn from an external point to a circle are equal. So this is a very important fact. So if this is an external point P, if you draw two tangents to the circle, the length of these two tangents are equal. So you will see that in the questions we will make use of these facts over and again. So let's get started with some of the questions. Question number 1, the length of a tangent from a point A at distance 5 cm from the center of the circle is 4 cm. Find the radius of the circle. So this is the circle. This is the point which is located outside the circle and it is at a distance of 5 cm. So let's say this is point A. Right, and let us also mark this as O, which is the center of the circle. Now the radius of the circle we do not know. Let us assume that the radius is R. Okay, and it says that the length of the tangent is 4 cm. So this is the tangent. So tangent has to pass from this point. So let's say this is the tangent and its length is given as 4 cm. So we have to find out the value of radius. Now we already know that the angle between the tangent and the radius is always 90 degrees, right? So that means this triangle that you see is a right angle triangle, which in turn means that the Pythagoras theorem will hold true in this case, which says hypotenuse square, this is the hypotenuse which is opposite to the 90 degree. So hypotenuse square is equal to perpendicular square plus base square. So r square will be equal to 25 minus 16, which is equal to 9. So r will be equal to 3 cm. So that's the radius of the circle. Let's look at the next question. A quadrilateral ABCD is drawn to circumscribe a circle. So what do we mean by circumscribe? So that means that the quadrilateral is drawn in such a way that a circle exactly fits inside it. So as you can see here, the circle is actually touching each side of the quadrilateral exactly at one point. So that is what we call as circumscribe. So prove that AB plus BCD is equal to AD plus BC. Now looking at this diagram, is there any theorem that comes to your mind which we can take help of? So just now we learned that the length of the tangents drawn from an external point are equal. So here if you see, D is an external point from where these two tangents dr and ds are drawn to the circle, which means that by that theorem dr should be equal to ds. Similarly, C is an external point and CR and CQ are the tangents. So CR should be equal to CQ. In a similar way, BP should be equal to BQ and AS should be equal to AP. So all these relations exist. Now let us try to prove this. So we will start with left hand side. So in the left hand side we have AB plus CD. So what is AB? AB can be written as AP plus PB. So AB can be written as AP plus PB and CD can be written as CR plus RD. Right? So now using these relations, what we can do, we see that AP is actually equal to AS. So let us write it as AS. Okay. Now what about PB? So PB or BP, it's the same thing, that is equal to BQ. So let's write it as BQ. Then we have RC or CR, which is equal to CQ. So let's write it as CQ. And then RD, which is equal to DS. Right? So now we see that BQ plus CQ. So BQ plus CQ is equal to BC. So this is equal to BC. And AS plus DS, that is equal to, these two together is equal to AD. So that means this is equal to AD plus BC, which is equal to right hand side, and we have successfully proved it. Let's now look at the third question. A triangle ABC is drawn to circumscribe a circle of radius 4 cm such that segments BD and DC into which BC is divided. One second. Okay, so the question says a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that BC is divided, such that this BC is divided into BD and DC, which are of lengths 8 cm and 6 cm respectively. So the words here have jumbled up slightly. Find the sides of AB and AC. So we have to find out the sides of these two remaining sides of the triangle. Okay, so here also let us assume a couple of things. So again, A being an external point and A, let's name this point as E, let's name this point as F. So AE and AF are tangents drawn from an external point, so they are of equal length. So let us say this is X, so this is also X, right? Now this portion CD is 6, so therefore CE will also be 6 with the same logic. BD is 8, so BF will also be 8 with the same logic, right? So these are some of the values that we could find out. Correct. So now if I talk about the three sides of the triangle, so let us say this is side A, this is side C, and this is side B. So these are, let us suppose, the three sides of the triangle. So A will be equal to 6 plus 8, that is 14 centimeter. B will be equal to X plus 6 centimeter. And C will be equal to X plus 8 centimeter. So these are the three sides of the triangle. So now let us try to find out area of triangle ABC. Right? So what is our whole idea in doing all of these? We basically want to find out the value of X. So what we will do, first we will find out the area of this entire triangle using Heron's formula. Then we will try to find out the area of this triangle by breaking it into 3 smaller triangles. So with that, we will equate both of these values, and that's how we will find out the value of x. So let us first make use of Heron's formula. So Heron's formula says that s in root over s into s minus a, s minus b, and s minus c, where s is the semi-perimeter. So s is equal to a plus b plus c divided by 2. So we already know the values of a, b, and c, 14, x plus 6, and x plus 8. So once we put all these values, so we get it as 14 plus x plus 6 plus x plus 8 divided by 2. So now let's calculate the area, which is equal to root over s. So s would be how much? This will be 14 plus 2x plus 14 divided by 2. That is 28 plus 2x divided by 2. So this will be equal to 14 plus x. So the area would be s into s minus a into s minus b into s minus c. So now when we actually calculate this comes out to be root over 48x square plus 672x. So I'm not doing the detailed calculation because you can very well do that. So this is the area that we are getting in terms of x by using Heron's formula. So now what we will do, we will make use of another concept to find out the area of triangle ABC. For example, we can say that area of triangle ABC will be equal to, let's say if we divide this ABC triangle into 3 triangles like this. So we can say that area of triangle AOC plus area of triangle AOB plus area of triangle COB. So this would also give area of triangle ABC. So how do we find out the areas of these smaller triangles? So area of triangle AOC would be half into base into height. Area of triangle BOC would be half into base into height. And area of triangle AOB would be half into base into height. So now when we calculate this, we get 4x plus 56. So now we can equate both of these, like the area of triangle ABC that we found using 2 different methods, that can be equated. So we can say therefore root over 48x square plus 672x is equal to 4x plus 56. So from this we can say 48x square plus 672x is equal to this entire whole square, that is a square plus b square plus 2ab. Again, when we do all the calculations, we see that x is equal to 7 or x is equal to minus 14. So negative value in this case is not possible because x was actually the length of a side. So therefore, this is the correct value. So if x is 7, in that case, the length of the sides A, B and C would be 14, 13 and 15 centimeter respectively. So in this way, we could do the calculation. So here I am not really focusing much on the calculation part because that you can do on your own. And this being a very quick recap video of the entire syllabus, so we are just doing it fast. So let's move ahead with the next lesson, which is surface areas and volumes. So this again is a high priority lesson and you can expect 3 to 5 questions. And some of the important topics are finding surface area of an object, area related to frustum, and I am sure all of you know what is a frustum. So frustum is, you all know what is a cone, like, right? So this is how a cone looks like, just like a cap, birthday cap you can say. So that's a cone. Now if you remove this top portion of the cone, then whatever you are left with is a frustum. So this is a frustum. So one good example of frustum could be a bucket. So if you would have seen a bucket of this shape, where it is slightly tapered towards the bottom, and this is how it looks like. So that's a frustum. So many a times you get questions related to frustum. Volume and surface areas of combination of sphere, hemisphere, cylinder, cone. In fact, that is one of the most important questions that are often seen in exam. And for solving all these questions, the basic thing that you need is you should know how to calculate volume, curved surface area, and total surface area of different solids like cube, cuboid, cylinder, cone, sphere, hemisphere. So you should know these three things for all of them, right? A very common doubt that often comes to a lot of children is, what is the difference between curved surface area and total surface area? So curved surface area is only the area of the curved surface, but total surface area means area of the curved surface plus area of the flat surfaces. So for example, when we, let's say if we talk about the cylinder, so when we say curved surface area, it only talks about this curve thing. It doesn't talk about the circle that you have on the top or the circle that you have in the bottom. But when we talk about total surface area, it talks about the curved surface area plus the surface area of the top as well as the bottom. So that is why you see curved surface area is 2 pi RH, but total surface area is curved surface area plus 2 pi r square. So 2 pi r square is for those two circles which are there on the top and the bottom. Right, so that's the difference. Recap of a very important complex concept here, because from this lesson you generally get combination of different shapes, and then you have to calculate volume or surface area. So one important concept here is that whenever you have a complex body, always remember that the complex body is made up of combination of simple shapes. For example, here if you look at this body, this shape, it's like a droplet. This basically is made up of a cone and a hemisphere. If you look at this shape, which is in the shape of a tablet or a toffee, it's made up of one cylinder and two hemispheres, right? So that's how you will have to visualize that what is that complex body made up of. So a complex solid can be broken into simple solids, and always remember that when you are dealing with surface area of a complex solid, that may not be the sum of the surface areas of the constituent solids, because some part of the surface area disappear in the process of joining them. For example, if you talk about this complex body, so the total surface area of this cone and the total surface area of this hemisphere, they do not add up, because if you look at this middle portion, that is vanished because both of them have combined, right? So now if you are dealing with the surface area, it is just the curved surface area of the cone and again only the curved surface area of the hemisphere. But when we talk about volume, that is when we are dealing with volume, so that time it is actually the sum of the volumes of the constituent solids. That means in this case, if we have to find out the volume of this complex body, that will be as simple as sum of the volume of the cone and the volume of the hemisphere. So when it comes to volume, we straight away add them up. But when it comes to surface area, we need to see that, what are the things that need to be added up, whether the total surface area needs to be added or not, because when they are joined, some of the surfaces disappear in the process of joining. So let's quickly look at some of the questions. So the first question is, a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. So remember, here you have to find its surface area. So what would be the surface area in this case? So it will be the curved surface area of the cylinder, because you have a cylinder like this. So the curved surface area of the cylinder and not the total surface area. And I hope you know why not the total surface area, because these two flat surfaces of the cylinder, they are no more there in the process of being joined with hemispheres, right? So only the curved surface area of the cylinder needs to be considered, and the curved surface area of both the hemisphere. That means 2 times the curved surface area of hemisphere. So now if you use the formula, so the curved surface area of a cylinder is 2 pi rh, and the curved surface area of a hemisphere is 2 pi r square. So this would be 2 pi rh plus 2 into 2 pi r square. So this would be equal to 2 pi r into h plus 2r. So now let's put the values. 2 into 22 by 7 into radius is given as, so diameter is 5 millimeters, so radius would be 5 by 2 millimeter. H, that is the height of the cylinder, which is given as 14 millimeter. So this would be, okay, so 14 millimeter is the entire length, not just the height of the cylinder. So from this 14, we will have to subtract the radius of the two hemispheres. So the radius of the hemisphere is how much? So obviously this, if this is the radius of the hemisphere, this is also the radius of hemisphere, right? So the diameter is 5 mm, so radius will be 2.5 mm, correct? So this is 2.5, this is also 2.5. So you need to subtract these 2.5 from 14. So what is the length of the cylinder? It will be 9 mm. Correct? So in this case, the height would be 9 and 2 into r. R is again 5 by 2. So now once you calculate this, it comes out to be 220 millimeters square. So that's the surface area of the capsule. Let's look at one more question. A gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and diameter 2.8 cm. So here again, if you look at the shape of the gulab jamuns, this is how it looks like, which is again a cylinder and two hemispheres on both the ends. Right? So let us first try to calculate the volume of one gulab jamun. So because if we are able to find that, then by multiplying that with 45, we will be able to find out the volume of 45 gulab jamuns. So volume of one gulab jamun would be equal to volume of the cylinder plus 2 times volume of the hemispheres. Because in case of volume, you remember, you just need to add up. That's it. Volume of cylinder plus 2 times volume of hemisphere. So volume of cylinder is pi r square h and volume of a hemisphere is 2 by 3 pi r cube. So even if you take pi r square common, it will be h plus 4 by 3r. So now you already have the values like h and r. R would be 1.4, that is diameter divided by 2. So in a similar way, you can find out the height of the cylinder, because this total length again is given as 5 and here the diameter is 1.4. The radius is 1.4 here. So here 1.4, here 1.4. So basically from 5, you will subtract 2.8. So you will get 2.2. So 2.2 will be the height of the cylinder. So this side you will have 1.4, this side you will have 1.4. And that's how you have the total length as 5. So putting these values, you will get volume of 1 gulab jamun as 25.05 centimeter cube. So now you can easily find out volume of 25 gulab jamuns, which will be equal to 25 into 25.05. Not 25 gulab jamuns, but 45 gulab jamuns. So this would be 45 multiplied by 25.05. So therefore, the syrup needed for 45 gulab jamuns would be 30% of the volume of gulab jamuns. That is 30% of this total volume. 30% of 45 into 25.05, and this comes out to be 338.185 centimeter cube. So I'm not doing the calculations, please do it on your own. Now, last but a very important topic is the frustum of a cone. As I told you that when you remove the upper part of the cone, whatever is left behind is called a frustum. Now, volume of the frustum is given by 1 by 3 pi h r1 square plus r2 square plus r1 r2, where r1 is the radius of the bigger base, r2 is the radius of the smaller top, and r is in between. Now, the curved surface area of the frustum of a cone is given by pi r1 plus r2 into L. Total surface area is given by pi L r1 plus r2 plus pi r1 square plus pi r2 square. So everywhere you see that in case of a frustum, there is no single radius but two radii r1 and r2 which are involved. So, but you do get questions related to frustum of a cone, so please pay attention. So here I have just given you the formulae for a quick recap, but I'm sure you must be knowing the concepts behind the formula. How do we get them? And please do practice a few questions based on this concept. So here comes the next lesson, that is probability. This is again a lesson where you can expect say 2 to 3 questions for sure. So some of the topics, like some of the popular questions in this lesson are the questions related to dice, card, tossing a coin, and things like that. So let's move ahead and do a very quick recap on the concepts of probability. So what is probability? It's like the possibility of a particular event occurring. So probability is number of favorable outcome divided by the total number of possible outcomes. So that's probability. We generally denote it as PE, where E is the event, which means the probability of an event is the number of trials in which the event happened divided by the total number of trials. Now let us take the example of the dice. Like when you play the Ludo, you make use of this dice. So you would have seen that it's a cube and it has the numbers 1, 2, 3, 4, 5, 6 written on all the 6 sides. So what are the total possible outcomes with a dice? So there is a possibility that when you throw a dice, you get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. You cannot get a 0 because there is no 0. You cannot get a 7 or a 8 because there is no 7 or 8. Right? So the total number of outcomes, the total number of possible outcomes is 6. So if I ask you what is the probability of getting a 2? So the probability of getting a 2 is 1 by 6 because the favorable outcome, that is possibility of getting 2, is only once out of the total number of possibility, which is 6. Similarly, if I ask you what is the probability of getting a 7? So the probability would be 0 because there is no 7. No 7 exists at all. So probability of getting a 7 is actually an impossible event because that can never happen. So normally the probability of any event lies between 0 to 1. It cannot, if it is 0, that means it is impossible, just like this one. And if it is 1, what does that mean? So 1 would mean a sure event or a certain event. That means there are 100% chances that it will happen. Let's assume, let's take an example. Let us suppose that we have customized this dice in such a way that you have 1 on all the 6 sides. So you do not have 2, 3, 4, 5 or 6. You just have 1 on all the 6 sides. So in that case, what will be the probability of getting a 1? It will be 1 because you do not have any other number on any of the sides. So no matter whichever way you throw, you will always get a 1. So in that case, that will be called a sure event. So if the probability of an event is 0, that means it is impossible, that can never happen. And if the probability is 1, that means it is a sure short event. That is what will happen. But other than that, the probability of occurrence of an event is always somewhere between 0 and 1. So let us look at a card problem in probability. Now, even before we start solving a card problem, you should know some of the basic things about card. So there are a total of 52 cards in a pack, and out of these 52 cards, you have 4 different varieties of card, like diamond, which is in this shape. You would have seen this, right? Similarly, you have the heart shape card, right? Then you have the club, and then you have the spade. So I'm not drawing all of them because I might not be able to draw them exactly. So anyways, you have these 4 different shapes of card, and in each of these cards, like for example, you have 13 diamond, you have 13 heart, you have 13 club, you have 13 spade. And again, diamond and heart, they are red colored, and club and spade, they are black colored, right? Now here again, what are these 13 cards? Now for in each category, you have A, which is like you call it the 1, then you have the jack, the king, queen, and then you have 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it's not 1 to 10, it's rather 2 to 10, because 1 is nothing but this A. So these are the cards that you have in each category. Now this is very important to understand. Now face card, there is something called face card. So face cards are the cards which are jack, king and queen. So they are called the face card because you actually see face of some person on those cards. Right. So now let's start solving the question. So the first question say, what is the probability of getting a king of red color? So you see what are the number of favorable outcomes. So how many kings do you have in red color? Only 2 possibility, either a diamond king or a heart king. So that means 2 is the number of favorable outcomes. And what is the total number of outcomes? Total number of card is 52. So total number of outcomes is also 52. So therefore the probability of getting a red king would be 1 upon 26. The second question says a face card. So how many face card, probability of getting a face card? So how many total face card do we have? So face card means jack, king, queen. So you have one jack, one king, one queen in diamond. Similarly in heart, similarly in club, similarly in spade. That means you have 12 face cards. So number of favorable outcomes would be 12 and number of total outcomes is 52. So this is 12. So this 12 by 52 would be the probability. Third question says a red face card. So how many red face card do we have? Jack, king, queen, jack, king, queen. So total 6. So probability of getting a red face card would be equal to 6 upon 52. Number 4. Probability of getting the jack of hearts. So what is the favorable outcome? Only 1, because jack of heart. So only for the heart you will have just 1 jack. So this would be 1 by 52. Fifth, probability of getting a spade. So how many spades do you have? 13 spades. So it will be 13 divided by 52. The last one, the queen of diamonds. How many queen do you have of diamonds? Only 1. So this would be 1 upon 52. So whenever you are trying to solve the card problem, before that just be clear with these concepts. Let's look at the next example. So it says a child has a die whose 6 faces show the letters as given below. A, B, C, D, E and A. The die is thrown once. What is the probability of getting A? So probability of getting A will be number of favorable outcomes. So what are the possibilities that A might come? 1 and 2. So 2 is the number of favorable outcomes. And what is the total number of outcomes? 1, 2, 3, 4, 5, 6. So 2 upon 6 would be the probability. Probability of getting a D. So number of favorable outcomes is just 1. So this will be 1 upon 6. So let's look at the third question. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. So you have a 1 rupee coin, you toss it 3 times and then note its outcome. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. So calculate the probability that Hanif will lose the game. So for that we will first have to see what would be the possible outcomes of this activity. So possibility is that you toss the coin 3 times and every time you get a head. There is a possibility that first 2 times you get head and then last time you get a tail. There is a possibility that you first get head, then you get a tail, then you again get a head. So in this fashion, we see that these are the possible outcomes. So the total number of possible outcomes is 8. And what are the favorable outcomes? Favorable outcomes are those, so we have to find out the probability where Hanif will lose the game, right? So probability of losing. So this has to be equal to number of favorable outcomes. That means what are the outcomes which favors losing the game? So Hanif will win only when all the three are same. Like if all are head or if all are tail, only then he wins. But what are the favorable outcomes which favors that Hanif will lose the game? So how many are there for losing? 1, 2, 3, 4, 5, 6. So the favorable outcomes for losing the game is 6. And total number of outcomes is 8. So 2 3s is 6, 2 4s are 8. So the probability will be equal to 3 by 4. So let us now start with real numbers. So real numbers, again you can expect some 2 to 3 questions. Some of the important topics in this lesson are HCF, irrational number, and product of LCM and HCF. So these are some very simple 2 to 3 topics, and you generally get questions related to these topics from this lesson. So let's get quickly started. So find HCF using Euclid's division lemma. So what is Euclid's division lemma? So it talks about an entire procedure by which without doing actual division, you can still do it. So this states that given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r. Now you will see that we will work on this relationship, and that's how we will find out HCF of two numbers. So these are some of the steps that we would follow. Apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to DQ plus R. So now as I read the steps, they won't make much sense to you. But when we take an example, you will understand it better. So let's start with the example. Find the HCF of 455 and 42. So our step 1 would be, we write it in this format of C is equal to DQ plus R. So we will write it in this format. So how do we write it? C is equal to DQ plus R. So 455 can be written as 42 into 10. So where 42 is this 42 into 10 plus 35, right? So here 455 is C and 42 is D. So in this case, what is R? R is 35, right? Now in step 2, if R is equal to 0, then D is the HCF of C and D. But that is not the case here. So in our case, R is not equal to 0. If R is not equal to 0, then apply division lemma to D and R. That means we still have to apply division lemma to D and R. So this is D and this is R. So that means D is equal to 1 into 35 plus 7. So we have applied the same division lemma here. So now in this case, what is R? So let's move on to step 3. So now again we have R not equal to 0. So that means we still need to apply division lemma to 35, which is D here, and 7, which is R here. So we will get 35 is equal to something into 7. So 5 into 7 plus 0. So now we have R is equal to 0, which means that D is the HCF of C and D. That means 7 is the HCF. So HCF is equal to 7. So we saw that without finding the actual HCF, we just made use of Euclid's division lemma to find out the HCF between these two numbers. So let's move on to the next question. Given that HCF of 306 and 657 is equal to 9, find LCM of 306 and 657. So even if I mean, one option is we do the LCM, but that's a lengthy process. So without doing that, if we just know the HCF, we can make use of this concept that the product of HCF and LCM is equal to the product of the two numbers. So that means LCM into HCF, which is 9, is equal to 306 into 657. So therefore, LCM will be equal to 306 into 657 divided by 9, which is equal to 22338. So that's the LCM. So let's do a quick recap on irrational number. So as the name itself tells us that it is exactly the opposite of rational number. So these numbers cannot be written in the form of p by q, where p and q are integers and q not equal to 0. So let us look at this example. Show that 3 plus 2 root 5 is irrational. Now, whenever we have a question of this kind where we have to prove that a particular number is irrational, the approach that we can follow is, let's assume that this number is rational. So let's assume that this number is a rational number. Now, if at all this is a rational number, then this should be written in the form of a by b or p by q, whatever you call it. So that actually means 2 root 5 is equal to a by b minus 3, which is equal to a minus 3b divided by b, or we can say root over 5 is equal to a minus 3b divided by 2b. Right? Now, if you compare left hand side and right hand side, you see that root over 5 is an irrational number. But when you look at this, here you see it is in the form of p by q, q not equal to 0. So this is a rational number. So this actually shows that, something was wrong. So basically our assumption was wrong. That means our assumption was wrong and 3 plus root 5 is an irrational number. So let's move on to the next lesson, which is triangles. So triangles again is a medium priority lesson, and you can expect 2 to 3 questions from these topics, like important theorems, finding length of diagonal, of rectangle, etc. In fact, there are a couple of theorems and you should know them really well, because you will have to apply them to solve a lot of questions. Finding angles or sides related to triangles, similarity of triangle. Now that's quite important. Pythagoras theorem or questions related to right angled triangle. So here, first we will do a very quick recap on some of the important theorems. The first being the Thales theorem. So Thales theorem states that if a line is drawn parallel to one side of a triangle, let's start drawing it simultaneously. So we have a triangle ABC. So if we draw a line parallel to one side of a triangle to intersect the other two sides, that is AB and AC, in distinct points, that is D and E. So that means DE is a line which is intersecting AB and AC at D and E, and this is also parallel to BC. So in such a case, the other two sides are divided in the same ratio. That means AD by DB is equal to AE by EC. So this is Thales theorem. Let's look at the next one, internal angle bisector. So this states that internal bisector of an angle of triangle divides the opposite side internally in ratio of sides containing the angle. So let us suppose this is a triangle ABC, and we are talking about an internal bisector of an angle. So let's say if this is, let's name this point as O. So let's say AO is the internal bisector of angle A. So this theorem states that it divides the opposite side internally in the ratio of the sides containing the angle. That means it is BO by OC. So it actually divides BC into two halves such that BO by OC is equal to AB by AC. So this is the theorem of internal angle bisector. Let us now look at the converse of internal angle bisector. It says that in a triangle ABC, if D is a point on BC such that, let's suppose D is a point on BC such that D divides BC in the ratio of AB by AC, AB is to AC, then AD is the angle bisector of A. That means if at all D is a point such that it divides BC in the ratio BD by DC is equal to AB by AC, that actually means that AD is the angle bisector of angle A. That means angle BAD is equal to angle CAD. So these are three important theorems here, and you may expect questions related to these theorems. Let's move on to the next theorem, which states that the external angle bisector of a triangle divides the opposite side externally in the ratio of sides containing the angle. So sometime back we learned about the theorem related to internal angle bisector. So it is a very similar thing, just that everything happens externally here. For example, let's draw the triangle first. So let's say this is triangle ABC. Now since we are talking about external angle bisector here, what we do is we just extrapolate these two sides so that we are able to understand which one is external angle bisector. Now AD here is the external angle bisector. How? Now if you look at the vertex A, this is the internal angle A, because this angle lies within the or lies inside the triangle, whereas this angle is the external angle A because it lies outside the triangle, right? So AD is the line which bisects the external angle A. Therefore AD is the external angle bisector. Cool. Now the theorem states that this AD divides the side BC in such a way. So if you see, AD is dividing BC externally, right? When you extrapolate BC using a dotted line, then only you see that AD is kind of dividing the side BC, right? So it divides BC externally in the ratio of sides containing the angle. Great. So now in this case, that means that BD, this entire thing, divided by CD is equal to AB by AC. That is the other two sides of the triangle. So this is the theorem of external angle bisector. So now we talk about criteria for similarity of triangles. What do we mean by similarity of triangles? Now there are certain criteria that needs to be fulfilled for two triangles to be similar. Now please understand that when we say similar triangles, that doesn't mean that the two triangles are equal. So the two triangles might not be exactly equal, but they are similar to each other. For example, here on the screen, if you see triangle ABC and triangle DEF, they are definitely not equal, because you see DEF is a smaller triangle as compared to ABC. But they are similar triangles. Why? Because they have certain similarity. For example, the values of their angles, they are similar. Besides that, the values of the length of their sides are proportional. Right? So that ways they are similar, but they are not equal. So do understand that. Now some of the criteria are, so two triangles are similar if all their corresponding angles are equal. For example, angle A equals to angle D, angle C equal to angle F, angle B equal to angle E. So their corresponding angles are equal, or the ratio of their sides are equal, that is their sides are not equal, like the value of the length of their sides are not the same, but the ratio of the sides are equal. That means AB divided by DE is equal to AC divided by DF is equal to BC divided by EF. That means their sides are proportional. So that's what it means. Okay, so when we talk about similarity of triangles, there are a couple of things that you must remember. That is, all congruent figures are similar, but all similar figures are not congruent. Two polygons of the same number of sides are similar if their corresponding angles are equal, their corresponding sides are in the same ratio. If in two triangles corresponding angles are equal and their corresponding sides are in the same ratio, then the two triangles are similar, and this criteria is called AAA criteria. That is angle, angle, angle. That means all the three angles are equal. If it so happens that two angles of a triangle are equal to the two angles of the other triangle, which anyways mean that the third angle would also be equal, but this criteria is known as AA similarity criteria. If it so happens that the corresponding sides are in the same ratio, so then that criteria is called SSS similarity criteria. If it so happens that one angle of a triangle is equal to one angle of another triangle and sides including these angles are in the same ratio, then that criteria is called SAS, that is side angle side. But here the important thing is that if we are talking about, let's say, this angle, then the two sides which should be in the same ratio are these two sides, like the sides which are enclosing that angle. Okay, so let's quickly look at some important facts related to ratios in similar triangles. Ratio of sides of two similar triangles is equal to ratio of their corresponding altitudes, that is heights. Ratio of sides of two similar triangles is also equal to their corresponding median. Ratio of sides is also equal to the ratio of their corresponding angle bisector. Now these are some important facts because again you may have to use these facts to solve some of the questions. Ratio of areas of two similar triangles is equal to the ratio of the square of their corresponding sides. Now these are some of the facts that you should definitely know, and I'm sure you all know what is altitude, what is median, and what is angle bisector. Angle bisector, the line which bisects the angle into two equal halves. Median, the line which divides the other side of the triangle into two equal halves. Altitude, the line which is perpendicular to the opposite side of the triangle, like drawn from one vertex. For example, AM, here is the altitude because it is drawn from one vertex to the opposite side, perpendicular to the opposite side. So that's altitude, right? But if at all, let's say if we are talking about median, then it has to be something like this. Let's say if this is ABC, so it doesn't matter whether it is perpendicular or not, but it divides BC into two equal halves. So that's median. If we are talking about angle bisector, so this is median. If we are talking about angle bisector in a triangle ABC, that means the line would actually bisect this into two equal halves. So angle BAD will be equal to angle CAD. So that's angle bisector. The ratio of areas of two similar triangles is also equal to the square of their corresponding altitude. Quickly look at Pythagoras theorem, which you have been studying since your junior classes. So let's look at this version. It says that square of the hypotenuse is equal to sum of the squares of the other two sides, and that's Pythagoras theorem. Now, if in a triangle square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right triangle. So basically this is the converse of Pythagoras theorem. So it says that if it so happens that in a triangle BC square is equal to let's say DC square plus BD square. So if this holds true for a triangle, that means it is a right angle triangle. And which angle is right angle? The angle opposite to the side BC. That means this angle D. So that means angle D is a right angle. So these are some of the important concepts based on which you get questions from the lesson on triangles. So please take a look at these concepts and solve questions. Moving on to the next chapter, that is Introduction to Trigonometry. From this lesson again, you can direct questions that you can expect from this lesson are maybe 1 to 3. So questions are generally asked related to trigonometric identities and trigonometric ratios. So it is more about solving. Like when you looked at the lesson on applications of trigonometry, that had more to do with problem solving, like you are given a situation and you need to relate it to trigonometry. But in this lesson, it's more about you are given trigonometric identities and you just need to solve them. For that, you should have a good grasp on the formula. So these are the trigonometric ratios like sine theta, cos theta, tan theta, cosec theta, sec theta and cot theta. And you must remember the values. Now they are pretty easy to remember. So if you know the values for sine theta for 0 degree, 30 degree, 45, 60 and 90 degree, it's very easy to remember for cos theta because it just goes the opposite of sine theta. Similarly, if you know it for tan theta, cot theta goes just opposite of tan theta. Similarly, if you know for cosec theta or sec theta, the other one is very easy to remember. So that ways you can very easily remember them. So now we will try a few questions. So let's say this is a trigonometric identity and you need to solve it. So sine 30 degree is 1 by 2, tan 45 degree is 1, cosec 60 degree is 2 by root 3, divided by sec 30 degree is 2 by root 3. Cos 60 is 1 by 2 and cot 45 is 1. So when you solve this, you get 3 by 2 minus 2 root 3 divided by 3 by 2 plus 2 by root 3. So now we will apply the technique of componendo and dividendo, because you see, if you look at the format, it's like a minus b divided by a plus b. So what we do? We do a, this entire thing is a. So we will do, if we assume this entire thing is a, this entire thing is b. So we will do a plus b divided by a minus b. So basically numerator plus denominator divided by numerator minus denominator. So this gets cancelled. So we get 3 divided by minus 4 by root 3, which is equal to minus 3 root 3 divided by 4. So basically solving these identities are pretty simple, just that you should be aware of the values of the trigonometric ratios. So let's try few more examples. Before that, let's look at the trigonometric ratios of complementary angles. For example, sine 90 minus theta or minus a is cos theta. Similarly, cos 90 minus theta is sine theta. Tan 90 minus theta is cot theta. Cot 90 minus theta is tan theta. Sec 90 minus theta is cosec theta, and cosec 90 minus theta is sec theta. Right? So now you will be able to see that when you look at these complementary angles ratio and when you compare it with the values of the trigonometry ratio in the previous screen, so you would see that there is a ratio. So here also you see there is a relation between sine and cos. Like complementary of sine is cos, complementary of cos is sine. Similarly, tan and cot, similarly sec and cosec. And that is why when you look at the table, if you know the table for sine, the cos is just the reverse. If you know the table for tan, cot is just the reverse. If you know the table for sec, cosec is just the reverse. Right? So pretty simple to remember because this is all logical. So a quick memory tip here is, so this is what I just discussed, that it's like you just remember 3 of them and the rest of the 3 would automatically be there in your mind, right? So sine and cos are together, tan and cot are together, similarly sec and cosec are together. So like not together in the sense they are similar. So if you know sec, it's just the complementary angle of that is cosec. So that ways. So this was about the complementary angles. So now let's look at some of the examples of trigonometric identities. So what is a trigonometric identity? Equation is called an identity when it is true for all the values of the variables involved. So you might have the confusion in your mind that even in an equation we have a left hand side, right hand side, both equating each other. So how does it differ from identity? So identity will hold true for all the values of the variables. For example, if you look at this trigonometric identity, so whatever the value of a is, this will hold true for all values of a, and that is why it is an identity, right? So here, so some of the examples are cos square theta plus sine square theta is 1, 1 plus tan square theta is sec square theta, cot square theta plus 1 is equal to cosec square theta. Again, these are some of the identities that you must remember because they are going to help you to solve other complicated identities, right? So let's look at this example. So we have to prove that this identity is true, correct? So let's start with left hand side. So left hand side is 1 plus tan square a divided by 1 plus cot square a. So cot square can be written as 1 upon tan square a, right? So this can be written as 1 plus tan square a divided by, so here you take tan square a, so this would be tan square a plus 1. So this becomes So this 1 plus tan square a and this 1 plus tan square a will get cancelled. So the answer would be tan square a, which is equal to the right hand side. Now in a similar way, I would want you to try this part, 1 minus tan a whole square divided by 1 minus cot a whole square. So a quick hint that I would like to give is 1 minus a minus b whole square. So use that concept and then just try solving. Try to write tan in terms of cot, and or try to write cot in terms of tan and get the answer as tan square a. So just try this yourself and I'm sure you'll be able to do it. So you can expect these kind of questions from trigonometry, like introduction to trigonometry. So moving ahead to the next lesson, that is area related to circles. Again, from this lesson, you can expect 2 to 3 questions, mostly from the concepts of area and perimeter of shaded region or objects. So here you would see that you will get different type of diagrams. It could be a sector, it could be a circle inside a quadrilateral or a triangle, and then you will be asked to find out areas of certain region. So let's do a very quick recap of the concepts in this lesson, which primarily consists of circumference and area of a circle. So a quick recap. So we all know how do we calculate circumference of a circle, which is 2 pi r, and area of a circle, which is pi r square. So the questions which are mostly asked from this lesson are related to area of the sector. So if you look at a circle, so this is how a sector looks like. It is made up of an arc and 2 radii. So they form a sector. Now any circle would have a minor sector and a major sector. For example, the smaller one where the angle involved is less than your 180 degree. So that would be your minor sector, and the other one would be the major sector. So this entire white region is major sector and the blue region is minor sector. Right. So how do we calculate the area of a sector? That is given by theta divided by 360 into pi r square, where theta is this angle. Right. Similarly, if we have to calculate the length of an arc of a sector of angle theta, so if at all we have to calculate the length of this arc, so how do we do that? Theta by 360 into 2 pi r, because this arc is actually part of the circumference of the circle. Right. So therefore we multiply it by 2 pi r. But when it comes to the area of the sector, it is part of the area of the circle. Therefore we multiply it by pi r square. So this is how we calculate area of sector. Now we also talk about segment in a circle. So a segment is formed by a chord and an arc. So again, there are 2 segments, minor and major. So minor, anything which is less than half of the circle, that's minor, and anything more than half of the circle is major segment. So here you see the blue region is minor segment, the white region is the major segment. So as I said, circumference area we already knew. So now let us talk about some of the questions. Let's look at some of the questions, because you do not get very straightforward questions from this lesson. You get questions which are like, you'll get a scenario and you will have to relate it to what is the area that you need to calculate. For example, on a square handkerchief, 9 circular designs, each of radius 7 centimeter are made. Find the area of the remaining portion of the handkerchief. So this is the handkerchief and you have total 9 circular designs like this. So you will have to find out the remaining portion of the handkerchief. That means these areas. So whatever is the remaining portion, that area you will have to find out. So how will you find that out? For that, first you can find out the total area of the handkerchief, basically the total area of this square. So that is something first you can find out, and then you can find out the total area of all the 9 circles. And then you can subtract the area of all the 9 circles from this area of the square. And that's how you will get this red regions. Right? So let's do that. So let us first find out the area of the handkerchief, that is the area of the square, which will be equal to side square. So in this case, what is the length of each side? So if you see, all that is given in this question is the radius of this circle is 7 centimeter. So how many such radii together makes this side? 1, 2, 3, 4, 5, 6. So that means each side will be equal to 6 into r, that is radius. So therefore each side will be 6r, and 6r whole square will be the area of the square. So this would be 6 into r is 7 centimeter, that is 7 into 6 into 7. So that would be 42 into 42 centimeter square. So that's the total area of the handkerchief. Now let us calculate the area of each circle. So area of each circle would be equal to pi r square. So pi is 22 by 7 into r is 7 into 7. So this is equal to 22 into 7. Therefore, area of 9 such circles would be 9 into 22 into 7. So therefore, the remaining portion will be equal to the total area, that is 42 into 42 minus 9 into 22 into 7. So when you calculate this, it comes out to be 378 centimeter square. So this is the area of the remaining portion of the handkerchief. Let's look at the next question. From each corner of a square, square of side 4 centimeter, a quadrant of a circle of radius 1 centimeter is cut. That means if you look at this, the radius is 1 centimeter. And also a circle of diameter 2 centimeter is cut. So this is a circle of diameter 2 centimeter. Find area of remaining portion of the square. So basically you will have to find out this blue shaded region. So how will you find that out? So first of all, find out the total area of the square, then find out the areas of these 4 corners, find out the area of the center circle, and then subtract these from the total area of the square, right? So let's do that. So let us first calculate the area of the circle which is at the center. That will be equal to pi into r square. So radius will be 1 centimeter. So pi into 1 into 1. So this is equal to pi centimeter square. Now let us calculate the area of the 4 quadrants which are at the 4 corners. So that will be equal to 4 times of area of each quadrant. So what would be the area of each quadrant? So quadrant is basically 1/4 of a circle, right? So that will be 1/4 of area of a circle, that is pi r square. Correct? So this 4 and 4 will get cancelled. So this would be pi centimeter square. So therefore, now let's calculate the total area of the square, the entire square, taken together everything. So that will be equal to side into side, and what is the length of each side? It is given as 4 centimeter. So this would be 4 into 4, that is 16 centimeter square. Therefore, remaining portion area would be equal to 16 minus pi plus pi, that is equal to 16 minus 2 pi. So now you can put the value of pi and calculate it yourself. So let's move ahead with the next lesson, that is constructions. Now this is a low priority lesson from where you really do not get too many questions, and you may get say 1 or 2 questions, not more than that. And some of the topics which are important are constructing tangent to a circle or constructing a similar triangle. So these are some things which are more important in this lesson. So let us see, we will just quickly do a recap of the steps to construct a scaled similar triangle. So given a triangle, construct another triangle whose sides are 3/4 of the corresponding sides of triangle. So let's say you are given a triangle. Now you will have to construct another triangle where the sides are 3/4 of the given triangle. So what are the steps that we normally follow? First, we draw a triangle ABC. So like this, ABC. Now we draw a ray AX making an acute angle with B, just like this. So this is AX. So now if you see here, this is AX making an acute angle with AB. Now we locate 4 equal points A1 to A4 on AX, like this, A1, A2, A3 and A4, right? Now we join A4B, just like this. So I'm just talking about the steps right now. Now we draw a line through A3 parallel to A4B to intersect AB at B dash. So you see we have drawn this line AB dash which is parallel to A4B. So these two are parallel. So we have drawn a line like this. Now draw a line through B dash parallel to BC to intersect AC at C dash. Right? So now what happens? What do you see? So you see that you ended up constructing a triangle A, B dash, C dash, which is similar to triangle ABC, but whose sides are 3/4 of the sides of ABC. So you see, logically, this was your triangle ABC, right? You just wanted the AB side to become AB dash, which is 3/4 of its side. So since we were looking for 3/4, so what we did, we divided this into 4 parts. So 3 parts out of 4 parts. So that corresponding point is 3/4 of AB. Now, once we were able to locate this point B dash, now then things were simple. Now, if you draw a line parallel to BC, that would actually mean that your AC dash is also 3/4 of AC. Correct. And meanwhile, when your AC dash becomes 3/4 of AC, AB dash becomes 3/4 of AB. So automatically B dash C dash also becomes 3/4 of BC. So this is how we draw a similar triangle. Right? Let's look at the next construction where we have to construct tangents to a circle from a point outside it. Okay. So first we draw a circle with center O. Okay. Now take a point P outside the circle. So this is point P outside the circle. Join PO and bisect it. So this is how we bisect a point. So you keep your compass at point O, draw this arc, draw this arc. Similarly, you keep it at point P, draw this arc, draw this arc. So this is how we draw a bisector, right? And then you bisect this line PO. Now let M be the midpoint of PO. Okay. Now taking M as the center and MO as the radius, draw a circle like this. Okay, so we did that. Now let this circle intersect the given circle at Q and R. So these are the 2 points Q and R where this circle intersects the given circle. Okay. Now join PQ and PR. So PQ and PR are the 2 required tangents. So why did we do so much of, complication? So since P was a point from where we wanted to draw these 2 tangents, what we wanted was these 2 tangents should touch the circle exactly at a point. At the same time, based on a theorem, we also know that tangents drawn from an external point are equal in length. That is, PQ is equal to PR. Correct. So that is also something which we already knew. So what we did was, so we basically took this point P, considering this distance of point P from point O as the diameter, we draw a circle. Now the moment we draw a circle, we get these 2 points, where it intersects the circle, and we just join those 2 points just to ensure that these are the 2 tangents drawn from an external point. Right? So these are the steps we follow to draw tangents. Now let's move ahead to the next lesson, which is pair of linear equations in 2 variables. This is again a low priority lesson and you can expect 1 to 2 questions. So the questions are generally related to different methods to solve linear equations in 2 variables, or sometimes boat or train related problems. Okay, so let's take a look at the quick summary. So 2 linear equations in the same 2 variables are called a pair of linear equations in 2 variables. The most general form of a pair of linear equations is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Here a1, a2, b1, b2, c1, c2, they are all real numbers, such that a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is also not equal to 0. Okay, so these are like the basics. So I'm not getting in too much into detail. Now a pair of linear equation can be represented and solved both by graphical method as well as algebraic method. So I will not get into the detail. I'll just quickly go through the methods. So if you talk about the graphical methods, so a pair of equation is represented by 2 lines. So 1 line for each equation. So if the lines intersect at a point, that means the set of equation gives a unique solution. That is why those two lines intersect at a specific point. So in such case, we say that the pair of equations is consistent. If the lines coincide, like they both overlap with each other, this is one line, this is another line, if that's the case, that means all their solutions are the same and they have infinitely many solutions, and we call such a pair of equation as dependent equations or inconsistent equations. So this is dependent equation. So to avoid confusion, let this be consistent, let this be dependent. And the third scenario, if the lines are parallel, then the pair of equations has no solution. So they never intersect at any point. So they have nothing in common. There's no solution at all. So such equations are called inconsistent equation. So with this, you understand that even just by looking at the graph, you can tell whether the equations are consistent, inconsistent, or dependent. Now, when we talk about algebraic methods, so there are certain methods, for example, substitution method, elimination method, cross multiplication method. So these are some of the methods which we will quickly discuss again, and based on the solutions that we get, when we solve these equations algebraically, we see that if a pair of linear equations are given by a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then a1 by a2 not equal to b1 by b2, in this case the pair of equations is consistent. a1 by a2 equal to b1 by b2 not equal to c1 by c2, that means it is inconsistent. And if all of them are equal, that means it is dependent and consistent. So inconsistent means no solutions exist. Consistent means they have just one unique solution. And dependent and consistent means they have infinitely many solutions, right? So there are several situations which can be mathematically represented by two equations that are not linear to start with, but we alter them so that they reduce to a pair of linear equations. So that's something which we generally do in order to solve real life situations. So let us now discuss each of these methods in little more detail. So we will take an example for each of these methods, and meanwhile we will also keep talking about the method. So as we talk about substitution method, here we have two equations, x plus y equals to 14 and x minus y is equal to 4. So to start with substitution method, as the name says, substitute. So we are going to substitute values in this case. So our step 1 would be to find the value of one variable in terms of the other variable. So for example, from this we can say y is equal to 14 minus x, right? So now as step 2, what we do? We substitute this value of y in the other equation, that is this equation. So what do we get? X minus 14 minus x is equal to 4. That is x minus 14 plus x is equal to 4, or 2x is equal to 18, or we can say x is equal to 9. Therefore y will be equal to 14 minus x, that is equal to 5. So we get x is equal to 9 and y is equal to 5. Now, there are a couple of cases that may arise. Okay, so once we obtain the value of x and y, there could be a situation that we get a true statement, as in we substitute the value of x or y that we obtained in step 2 and we use it in step 1 to obtain the value of the other variable. That is what we exactly did here. We found the value of x as 9, then we substituted the value for x, and then we found out y, which is 5. So that is our case 1. Case 2 could be if we obtain a false statement involving no variable. Then the original pair of equations has no solution, that is, it is inconsistent. So let us take an example of case 2. So let us suppose your equations where x plus y is equal to 14 and x plus y is equal to 4. Let us suppose this was your equation. So in this case, if you follow the same substitution method, you will get y is equal to 14 minus x. When you substitute that in this equation, you would get x plus 14 minus x is equal to 4. that is x plus 14 minus x is equal to 4. So you will see that x and x will get cancelled, and therefore what you get is 14 is equal to 4. Is this a true statement? 14 and 4 can never be equal. So what we get is a false statement. Now whenever we arise at a situation like this, that actually means that the equations has no solution. That means the equations which were given to us, they are inconsistent. They do not have any solution. Now there could be a third case where we obtain a true statement involving no variable. That means the original pair of equation has infinitely many solutions. So again, let us take an example of infinite solution. That is case 3. So let us suppose you have two equations, 3x minus y is equal to 3 and 9x minus 3y is equal to 9. So these are the two equations that you have. Do the same substitution. So y is equal to 3x minus 3. Now you put that value in this equation. So this would be 9x minus 3 into 3x minus 3 is equal to 9. So now as you solve this equation, what do you see? You get 9x minus 9x plus 9 is equal to 9. So 9x and 9x will get cancelled. So what we get? We get 9 is equal to 9. Now this is true because 9 and 9 are equal, obviously. But there are no variables in it. So how do we solve it? So we can't find out the value of x or y because there are no variables in this equation. So this is a scenario which means that the original pair of equations which were given to us, they have infinitely many solutions. Right, so I hope this is clear now. So that is substitution method. Now let's move ahead and talk about the next method, which is elimination method. So again, we will take an example. So we have two equations, x plus y is equal to 7 and 2x plus 2y is equal to 14. Now as part of elimination method, what we do is we multiply both the equations by some suitable non-zero constant so that we make the coefficient of either x or y numerically equal. So our whole target is to make the coefficients equal. For example, here the coefficient of x is y, here it is 2. Here the coefficient of y is 1, here the coefficient of y is 2. So what we do is, let us suppose we multiply the first equation by 2. So what happens? This becomes 2x plus 2y is equal to 14. So now the coefficients become equal. Then in next step, we add or subtract this equation from the other equation so that one variable gets eliminated. So this is my first equation and this is my second equation. So here we see eventually that both the equations are same. So now if we add these two equations, then what happens? Then both the variables will remain. So none of the variables will get eliminated. If we subtract them, then both the variables vanishes off and we get 0 is equal to 0. Now this again, let's look at the situations now. So in case 1, let us suppose if we obtain a true statement like how we got here. So it is a true statement but with no variable. That means they have infinitely many solutions. Second scenario could be we obtain a false statement with no variable. That would mean that the original pair of equation is inconsistent. It has no solution. So let's take an example of that kind, the no solution types. So let us suppose you have two equations, x plus y is equal to 7 and 2x plus 2y is equal to 5. Now in order to make the coefficients equal, we multiply the first equation by 2. So this becomes 2x plus 2y is equal to 14. Right? Now what we do is 2x plus 2y is equal to 14 and 2x plus 2y is equal to 5. Now when we subtract these two, what happens? This becomes 0 and this becomes 9. So this is a false statement. This means that the equations which were given to us, they do not have any solution, that they are inconsistent. The third situation could be that we get a value of x and using that value of x, we are also able to find out the value of y. So that's like the good scenario. So let us take an example for a finite solution case also. So let us suppose in this case, we have say two equations, x minus 5 is equal to 3 into y minus 5 and x plus 10 is equal to 2 into y plus 10. So basically if you kind of solve these equations. So what you get is x minus 5 is equal to 3y minus 15 and x plus 10 is equal to 2y plus 20. So these are the two equations, right? So now here we see there is no need to multiply because the coefficient of x is already the same. So what we can do is we can just subtract these two equations. So x gets eliminated. So we get, so on this side we get minus 15 is equal to y minus 35. So y is equal to plus 35 minus 15, which is equal to 20. So y is equal to 20. Now x is equal to minus 10 plus 3y, which comes out to be 50. So basically x you can find out, right? Because x minus 5 is equal to 3y minus 15. So y is 20. So put that value, so you will get x as 50. So this is the third scenario where you have a finite solution. X is equal to 50, y is equal to 20, right? So these are the cases for elimination method. Let's now talk about cross multiplication method. So we will very quickly look at the steps. So let us suppose we are given these two equations, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 is equal to 0. Now, what exactly we do in a cross multiplication method is that we multiply the first equation with b2 and the second equation with b1. Why do we do that? So that, the coefficient for the middle term becomes the same. Okay, now here what we are trying to do is, I'm just trying to tell you how exactly we derive an expression to calculate the value of x and y. However, in your exam, you really do not need to derive it. So from this, when we subtract these two equations, so we get a value of x, which is given by b1c2 minus b2c1 divided by a1b2 minus a2b1. So this is what we get for x. Now once we know the value of x, we can substitute this value and we get the value of y as c1a2 minus c2a1 divided by a1b2 minus a2b1. Now, a lot of you might feel it a little heavy to calculate, to remember in fact, this expression to calculate x and y, because you have so many b1, c1, b2, a2, c2, so many things, right? So here I'm going to share with you a memory tip. So, and this memory tip helps you to remember how do you calculate x and y. So this is the memory tip. X by b1c2 minus b2c1. Now if you notice this, that in the given equations, so a1 and a2 are the coefficients of x. So if you look at the denominator, except x coefficient, you have the other coefficients like b1, b2, c1, c2, right? Similarly, y divided by, you do not have y's coefficient, that is b is not there. You just have c1, a2 minus c2, a1. And then at last you have whatever is pending, that is a1, b2 minus a2, b1. So a lot of other people remember it in this way, like x, y and 1, which is the numerator, and in the denominator you have b1c2 minus b2c1, y divided by c1a2 minus c2a1, and a divided by a1b2 minus a2b1. So these are different ways of remembering this particular expression. So now you understood that this is how we calculate the values of x and y. Now again, in this case also, there are many different possibilities. Now depending upon this value, a1, b2 minus a2, b1, you actually can find out like what kind of solution will this equation have. For example, the equation may have finite, that is definite solution. It may have infinite solution. It may have no solution, right? So what kind of solution will this equation have? That entirely depends upon this value, that is a1, b2 minus a2, b1. So we have a couple of scenarios. For example, there is one scenario which says that if this value is not equal to 0, or in other words, we say that if a1 by a2 is not equal to b1 by b2. So both means the same thing, right? So if you just shift this a2, b1 on right hand side, so that's what you get, that a1, b2 and a1 by a2 is not equal to b1 by b2. In that case, the equation has a definite solution. But if A1 by A2 is equal to B1 by B2, in that case we again have two possibilities. One possibility could be A1 by A2 is equal to B1 by B2 is equal to C1 by C2. In that case we have infinitely many solutions. And if A1 by A2 is equal to B1 by B2 but is not equal to C1 by C2, in that case we have no solution. Right, so we saw that in each of these methods, whether it is substitution or elimination or cross multiplication, so everywhere we see that we have these possibilities: definite solution. In certain scenarios it has infinitely many solutions, and in certain other scenarios there is no solution at all. Now for this particular method, that is cross multiplication method, we will take example for each of these categories. So let us first take an example of a scenario which gives finite solution. So let us assume that we have these two equations. So here A1 is equal to 2, A2 is equal to 3, B1 is equal to 1, B2 is equal to 2, C1 is equal to minus 5, and C2 is equal to minus 8. Right, because so the equation that we are talking about is A1x plus B1y plus C1. That means this 5 has to be shifted to the left hand side. So we get 2x plus y minus 5 is equal to 0. And that is why C1 is equal to minus 5. Okay. Now let us find out the value of A1 B2 minus A2 B1. And that comes out to be 4 minus 3 is equal to 1, which is not equal to 0. So therefore this equation has definite solution or finite solution. So the value of x will be equal to b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1, which is 1. Now let's put the values: 1 into minus 8 minus 2 into minus 5. This is equal to minus 8 plus 10, which is equal to 2. So the value of x is 2. Now once we know x, we can very easily also calculate the value of y. So I think you can do this on your own. Let's move on to the next example. Now the next set of example that we have, this is an example of no solution scenario. So let's see. So here we have a1 is equal to 1, b1 is equal to minus 3, c1 is equal to minus 3, and a2 is equal to 3, b2 is equal to minus 9, and c2 is equal to minus 1. Right? So again, let's calculate a1 b2 minus a2 b1, which is equal to 1 into minus 9 minus 3 into minus 3, and that's equal to minus 9 plus 9, which is equal to 0. Right? Now here, that means here we have arrived in the second case where a1 by a2 is equal to b1 by b2. Now whether it has no solution or it has infinite solution, to identify that we have to see whether a1 by a2 is equal to b1 by b2 is also equal to c1 by c2 or not. Right? So let's calculate c1 by c2 in this case, which is equal to 3 by 2. But if you see a1 by a2, that is equal to 1 by 3. So that means in this case a1 by a2 is equal to b1 by b2, and this is not equal to c1 by c2. So therefore it has no solution. Now instead of doing this calculation, another alternative simpler way is you directly find out a1 by a2, b1 by b2 and c1 by c2. And looking at their ratios, you can identify which case it falls into. Let's look at the third example, which is obviously the third scenario of infinite solution. Right? So in this case, what do we see? We see that a1 is equal to 3, a2 is equal to 6, b1 is equal to minus 5, b2 is equal to minus 10, c1 is equal to minus 20, and c2 is equal to minus 40. Now if we look at this, we see that a1 by a2 is equal to 1 by 2, this which is also equal to b1 by b2, which is also equal to c1 by c2. So all of these are equal. Therefore this is a scenario of infinite solution. Now let us look at a question which is based on these concepts of solving equations. In fact, you may get these kind of question in your exam as well. So let's look at this one. A boat goes 30 km upstream and 44 km downstream in 10 hours. Now, Even before we go ahead, I hope all of you know what is the meaning of upstream and downstream. If you do not know this, please understand it right away. For example, let us suppose this is the direction in which the water in the river is flowing. So that's the direction of the water. And if the boat is moving in this direction, this is called upstream, that is opposite direction. And if the boat is moving along the same direction, that is called downstream, right? So whenever we talk about upstream, so any upstream movement, so the net speed gets subtracted because both of them are not moving in the same direction. But whenever we talk about the downstream, the net speed gets added up because they are both moving in the same direction, right? So that's one thing. So upstream would always means something getting subtracted, downstream would mean something getting added up. Okay, so in 13 hours, it can go 40 kilometer upstream and 55 kilometer downstream. Find speed of the stream and boat in still water. Okay, so let us assume that the speed of the boat is x kilometer per hour and the speed of the stream is y kilometer per hour. So we assume that. Okay, so in that case, what would be the speed downstream? So as I said, downstream means the speeds will get added up. So that would be x plus y. And what would be the speed upstream? They'll get subtracted and they'll be x minus y, right? Now, according to the question, time taken to cover 30 kilometer upstream plus the time taken, let's assume that T2, to cover 44 kilometer downstream, this entire thing is equal to 10 hours, right? So this is basically, so what is the time taken? So time taken is always distance traveled, which is 30 kilometer divided by speed. So speed here is x minus y because it is upstream, plus time taken to cover 44 kilometer downstream. So 44 divided by x plus y is equal to 10. Now when we further simplify this, now in a similar way, okay, so let's assume that this is our first equation. Now the second equation would be, it says in 13 hours it can go 40 kilometer upstream and 55 kilometer downstream. That means 40 divided by x minus y plus 55 divided by x plus y is equal to 13. So now we have these two equations, correct? But they look very complicated. So in order to simplify them, let's assume that 1 by x minus y is equal to u and 1 by x plus y is equal to v. Now if we put these values, we get 30u plus 44v is equal to 10 and 40u plus 55v is equal to 13. So now we have two equations in a relatively simplified version. Now you can choose any of the methods, substitution method or elimination method or cross multiplication method. So let's go with say substitution method. So now as per the substitution method, we can say u is equal to 10 minus 44v divided by 30, and we can put this value in the equation. So we get 40 into 10 minus 44v divided by 30 plus 55v is equal to 13. So now we just have only one variable, that is v, in this equation. So this becomes 4 into 10 minus 44v divided by 3 plus 55v is equal to 13. So this can further be written as 40 minus 176v plus 165v is equal to 39. So from this we can say, so I'm just doing very simple calculation. So this is minus 11v is equal to minus 1. So v is equal to 1 by 11. So once you know the value of v, now you can calculate u. You can put the value of v in this equation and you can get u. Now once you know get u and v, then you can very easily calculate x and y. So I leave this for you to solve. Yeah, but please remember that these type of boat river questions are quite important from exam perspective. So moving ahead to the next lesson, which is polynomials. So this one again is not so high priority lesson. In fact, you can consider this as a low priority lesson, and you generally get questions related to finding zeros of a polynomial or finding value of a variable. So those are basically the questions that you get. So let's look at a quick summary of this lesson. So here we generally discuss about polynomials of different degrees. So polynomials of degree 1, 2 and 3 are respectively called as linear, quadratic and cubic polynomials. A quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c, where a, b, c are real numbers with a not equal to 0. Okay, the zeros of a polynomial are precisely x coordinates of points where graph of y intersects the x-axis. Now, since it is a quick recap, so I'm assuming that all of you know what do you mean by zeros of a polynomial. But still, for those who do not know, I would quickly like to tell that zeros of a polynomial are those values for which the entire value of the polynomial becomes 0. For example, if we are talking about a polynomial px, now the moment you put the value of x as some k such that p of k is equal to 0, then we say that k is a zero of a polynomial. Now, when we talk about it graphically, what we mean is, let us suppose that this is our y-axis and let's say this is our x-axis. So let us suppose if we have a graph like this. Let's say this is the polynomial px. So that point where the value of this polynomial is 0. So this is that point. So at x is equal to k, this k is basically the 0. So that is why we say that 0 are the x coordinates. So if you see, this is x coordinate of the point where the graph of px intersects the x-axis. And that's exactly what's happening here. So even if you take few other examples, let us suppose if you have a graph like this. So where do you have the zeros of the polynomial? So basically the zeros are here. So these are the points on the x-axis which are zeros of the polynomial. Similarly, if you have a graph like this, so this has two zeros, 1 and 2. So this polynomial function has two zeros, right? So that's what we mean by zeros of a polynomial. A quadratic polynomial can have at the most 2 zeros, and a cubic polynomial can have at the most 3 zeros. If alpha and beta are the zeros of a quadratic polynomial, then alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. Here a, b, c are the coefficients of the polynomial. So please understand the difference between coefficient and zeros. Zeros means if you put those values, that means if instead of x you put the value alpha, so this entire polynomial becomes 0. So that's what we mean by zeros of a polynomial. So alpha and beta are zeros of the polynomial. A, B, C, they are coefficients of the polynomial. Right? So this is what the relationship is between zeros and coefficients of a polynomial. So this is again another relationship. So if we talk about a cubic polynomial, in that case, if alpha, beta and gamma are the zeros of the polynomial, then alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. The division algorithm states that given any polynomial px and any non-zero polynomial gx, there are polynomials qx and rx such that px is equal to gx into qx plus rx. So if you remember, we learned about something like this: dividend is equal to divisor into quotient plus remainder. So here it is exactly the same thing, just that each of these things is replaced by a polynomial. So px is the polynomial which is equal to the polynomial which is dividing px multiplied by the quotient polynomial plus the remainder polynomial. So that's the division algorithm. Now let us quickly look at a few questions. So question number 1, find zeros and coefficients of 6x square minus 3 minus 7x. So looking at this equation, we see that the value of a is equal to 6. A is 6, B is minus 7 and C is minus 3. So from this, we can calculate the value of alpha plus beta. So let's say that alpha and beta are the zeros of this particular polynomial. So alpha plus beta is equal to minus b by a, which is equal to 7 by 6. Alpha into beta is equal to c by a, which is equal to minus 3 by 6, that is equal to minus 1 by 2. Right? So from this we can say that alpha is equal to minus 1 by 2 beta. Now, we also know that alpha plus beta is equal to 7 by 6. So we can put the value of alpha is equal to minus 1 by 2 beta here. So this becomes minus 1 by 2 beta plus beta is equal to 7 by 6. Now this, when you keep solving this, so you get an equation like this: 12 beta square minus 14 beta minus 6 is equal to 0. So I'm not going to show all the steps because that's going to consume a lot of time, and this is a very quick summary video, so you can do the calculations on your own. So from this you can say that, so if you divide it by 2, the entire equation, so you get 6 beta square minus 7 beta minus 3 is equal to 0. So now if you do midterm splitting, so you can write it as 6 beta square minus 9 beta plus 2 beta. So minus 9 plus 2 is minus 7 beta, and minus 9 into 2 would be minus 18 beta square, right? So this is equal to 0. So from this we can say that 3 beta into 2 beta minus 3 plus 2 beta minus 3 is equal to 0, or we can say that 2 beta minus 3 into 3 beta plus 1 is equal to 0. So beta is equal to 3 by 2, or beta is equal to minus 1 by 3. So therefore alpha is equal to minus 1 by 3, or alpha is equal to 3 by 2. So basically the zeros of this, so the coefficients are 6, minus 7 and minus 3, and the zeros are minus 1 by 3 and 3 by 2. So let's look at the next question. It says that obtain all other zeros of 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root over 5 by 3 and minus root over 5 by 3. So basically looking at this equation, we see that the highest power of the equation is 4. So therefore this equation can have at the most 4 zeros, that is total 4 zeros. So 2 we already know, 2 more we will have to find out. So in this case, alpha is given as root over 5 by 3, beta is given as minus root over 5 by 3. Right? So we can say that x minus alpha and x minus beta. So x minus alpha, x minus beta is a factor of the given polynomial fx. So let's say we call this polynomial as a function of x, right? Because since alpha and beta are the roots, that means if you put these values to this equation, the value of the equation will be 0. So basically this will divide the equation exactly. So we can say x minus alpha into x minus beta should be a factor of fx, correct? So now that actually means x, what is x minus alpha, x minus beta? That is x minus root over 5 by 3 and x minus root over 5 by 3, that is x plus root over 5 by 3. So this is in the form of a minus b into a plus b, which is a square minus b square. So this would be x square minus 5 by 3. So that means this fx should be divided by x square minus 5 by 3. Right? Now this can be very well written as 1 by 3 into 3x square minus 5. Correct? So what we will do, we will now divide the polynomial fx by 3x square minus 5. So that's what we will do. 3x square minus 5, and here we have 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. So this would be like the simple division. So 3x square when multiplied by another x square gives us 3x to the power 4. Right? Now when you subtract this, this becomes 0. So now we have 6x cube minus 2x square minus 10x minus 5. Now 3x square multiplied by 2x gives us 6x cube minus 10x. So this is minus 10x. Now when we again subtract this becomes 0. This also becomes 0. So we are left with minus 2x square minus 5. Okay, I think something that we missed out is when we multiplied it by x square, this minus 5 also get multiplied by x squared. So here also we get another minus 5. So therefore this becomes plus 3x square. So here we have plus 3x square minus 5. Now 3x square minus 5 multiplied by 1 gives us 3x square minus 5. So the remainder is 0. Correct? So that means the other zeros are this. So this represents the other zeros. So now let's simplify this. So x square, a square plus 2ab plus b square. So that is a plus b whole square. So that means x is equal to minus 1 is the other root. Right? So therefore is the other zero basically. So therefore the given polynomial fx can be written as x minus root over 5 by 3 into x plus root over 5 by 3 into x plus 1 into x plus 1. So the four roots are minus root 5 by 3 plus root 5 by 3 plus 1 and plus 1. So let's look at the next question on dividing x cube minus 3x square plus x plus 2 by a polynomial gx. The quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find gx. So we all know that dividend, that is fx, is equal to gx, that is divisor into quotient plus remainder. Right? So what is fx in this case? It is x cube minus 3x square plus x plus 2. This is equal to gx multiplied by quotient is x minus 2 plus remainder is minus 2x plus 4. So now in this case we can say that gx is equal to x cube minus 3x square plus x plus 2 minus 2x plus 4. This entire thing divided by x minus 2. So this comes out to be x cube minus 3x square plus 3x minus 2 divided by x minus 2. So we just need to do the division now. So x minus 2 is dividing 3x cube minus 3x square plus 3x minus 2. So this would be x square. So this is x cube minus 2x square. So this is cancelled. So this would be minus x square plus 3x minus 2. So this would be minus x. So this is minus x square plus 2x. So this is getting cancelled. So this would be x minus 2. So this is plus 1, x minus 2. So therefore, the correct answer for gx would be x square minus x plus 1. So this should be the value of gx. So let's move ahead with the last lesson of the syllabus, that is statistics. Now in real life, data is generally huge, and for meaningful study of such huge data, we talk about statistics, where we do a lot of grouping of data. Now from your exam perspective, you can expect questions from statistics, from topics related to median of group data or cumulative frequency. So basically in this lesson, you will learn about three things: mean, median and mode. So this is a low priority lesson and you can expect 1 to 2 questions from this lesson. So let's do a quick recap. So here we will talk about 3 different things, that is mean, median and mode. So here I have roughly written down the formula for each of these, but I would like to quickly tell you about each of these. So when we talk about mean as we all know is the average. But when we have huge data like some 400, 500, 600 data, so calculating mean just by this method is not good enough. So for calculating mean, we will talk about 3 different methods and when do we use them. Next comes mode. So when we talk about mode, it is a value among the observations that occurs most often. right? For example, if I ask the students in my class, which is your favorite fruit? A lot of them might say apple, a lot of them might say banana, orange, pomegranate, etc. Now let's say if apple is one such fruit which is getting repeated multiple number of times. Let's say the number of people opting for apple is maybe more than 50% of the class. So that value becomes the mode. So mode is basically that value amongst the observation that occurs most often. That basically the one with maximum frequency. So that's mode. Next comes median. Median. The word median actually means it is the value of middlemost observation in the data. For example, let's say if I want to measure the height of all the students in my class. So a lot of them might be a little shorter, some of them might be quite taller, but when we talk about median, what we mean is what is that middlemost observation, like what is that middlemost value of height in that data of height of all the students in the class. So basically when we talk about median, it is the middlemost observation in the data. Right? So now, so that's pretty much about mean, median and mode. So if you look at the formula for mode, you see a lot of things here. For example, what is this F1, F0, F2? So what are these? So basically F1 is the frequency of the modal class. Now you again may ask, what is a modal class? So whenever we have to calculate mode, we first need to identify the modal class. It is basically the class with maximum frequency. So that's the modal class. So the frequency of the modal class is F1 and F0 is the frequency of the class preceding the modal class, just before the modal class, whichever class is there, that's frequency. And F2 is the frequency of the class which is succeeding the modal class. So modal class, before modal class, that's F0, after modal class, that's F2. Right? Now when it comes to calculating median, so here we see we have n by 2, where n is the number of observations, minus CF. CF is the cumulative frequency of class preceding the median class, divided by F. F is the frequency of median class, and H is the class size. Right? So I'm not getting too much again into detail. So just a quick brief. So there are these three methods available to calculate mean: direct mean method, assumed mean method, and step deviation method. So I'll not get into the derivation of the formula, just understand when do we use each of these formula. So the choice of the method would depend on the numerical values of xi and fi. So if xi and fi are very small, we use direct mean method. If xi and fi are large numbers, we use assumed mean method. And if the class sizes are unequal and also xi is large, there we use the step deviation method. So depending upon the situation, we can choose one of these methods. So let's look at a question. Following data gives information on observed. So the question says, following data gives information on observed lifetimes in hours of 225 electrical components. Determine the modal lifetimes of the components. Okay. So here we have these classes like in hours, like 0 to 20 hours, 20 to 40, 40 to 60, 60 to 80 and so on, and also the frequency. Right. Now looking at this table which is given here, first of all we need to identify the modal class. And what is a modal class? The class with maximum frequency. So the maximum frequency is here 61, and which is that class 60 to 80. So basically 60 to 80 is our modal class. Now if we quickly recap the formula to calculate the value of mode, so we would see that we would need certain values like L, H, F1, F0, F2. Right? So the value of L here is 60, which is the lower limit of the modal class. H is class size, which is 20, 60 minus 80. F1 is the frequency of the modal class, which is 61. F0 is the frequency of the class before the modal class. So that is 52. And F2 is the frequency of the class after the modal class. That is, this one is 38. Right? Now, once we know all of these values, we can calculate mode based on the formula, which is L plus F1 minus F0 divided by 2 into F1 minus f naught minus f2 multiplied by h. So after that, I leave it to you to calculate. So this is how you calculate the mode of this particular data. So let's look at the next question. The lengths of 40 leaves of a plant are measured correct to the nearest millimeter, and the data obtained is represented in the following table. Find median length of leaves. Okay, so here we have to calculate the median. Right? Now here one interesting thing that we notice from this table is the upper limit of the first class is not the same as the lower limit of the second one. That means that this is not a grouped data. So first of all, we need a grouped data, like whatever formula we have learned, mean, median, mode, we need a grouped data. So in order to make it a grouped data, what do? We subtract 0.5 from the lower limit and add 0.5 to the upper limit. So what happens that ways? So from the lower limit, we subtract 0.5. So it becomes 117.5. To the upper limit, we add 0.5. So it becomes 126.5. Similarly, for the next interval, again, we subtract 0.5 from the lower limit. So this becomes 126.5. We add 0.5 to the upper limit. So it becomes 135.5. So if we continue doing this, this is what we get. So we basically get a grouped data. That is, the upper limit of the first class is equal to the lower limit of the second class. And that is what we wanted. Right? So in this fashion, we can continue. Right? Now here, if you look at the frequencies, this is how it is. 3, 5, 9, 12, 5, 4, 2. Right? Now, if you want to calculate the cumulative frequency, then what is this? This is 3. This would be cumulative, means even if we are calculating the frequency for this class, the entire frequency till that time will be summed. So that means here it will be 5 plus 3, that is 8. Here it will be 9 plus 8, that is 17. Here it will be 12 plus 17, that is 29. So in this fashion, we calculate the cumulative frequency. Right? So what is the, so now let's make use of the formula for median. So even before we do that, we will have to identify the median class. So here value of n is 40. Number of observations is 40 because we are dealing with 40 leaves of the plant. So what is n by 2? N by 2 would be 20 and n by 2 plus 1 would be 21. So that means which is that class that has frequency values 20, 21. Look at this, we do not have the exact value of 20 or 21, but the nearest value would be 29 and this class would be the median class. So we call this as the median class. Right? So if this is the median class, so now we can say that the value of L would be 144.5, N is anyways 40, cumulative frequency is equal to, so CF is cumulative frequency of the class preceding the median class. So that means cumulative frequency in this case would be 17. F will be equal to 12, that is frequency of the median class. So this is the normal frequency. This is F and this is cumulative frequency. Okay, and then we have H, which is class size, that is equal to 9. So now we can put it in the formula for median and we can calculate. So I am not going to do the calculation, so you can do it on your own. Right? So with this, we have reached towards the end of this video on Crash Course Class 10th Maths, and I hope that you found this video useful. So in this entire video, we tried to cover the entire syllabus, but only the important topics, and I also try to give you some idea on the weightage and the type of questions that you might expect from each of these topics. I'm sure you are going to rock your exam, so keep practicing, keep revising. I wish you all the very best.